right, cool. So welcome to this workshop. My name is Peggy Zhu, and I will be your trainers for this workshop. So I'm a UC Davis student. I recently graduated in June, and I got my Bachelor of Science in Electrical Engineering and Computer Engineering. So starting this year, I will be a first-year graduate student, and still at UC Davis. So I have a 2 hours difference between you guys. If I misspoke about my time, let me know. We'll be taking a break at 1 p.m. CT, and that's a long break from 1 p.m. to 1:45 p.m. And other than that, every hour we will aim for about 5 to 10 minutes break. Okay, so let me first give the floor to our coordinator, Jackie. So Jackie has been helping to coordinate these workshops. And Jackie, do you mind unmuting yourself and introduce yourself?
Thank you, Peggy. No problem. So my name is Jackie, and I manage our team sponsorships program here at Altium. So we have almost 700 teams globally, similar to your team, that do robotics, that do rocketry, that do Formula student competitions, sailboat competitions, drones, like anything you name it, we have a team that does it. It's a really exciting program. The workshops are a new addition to the offerings that we're giving our teams. So it's been exciting. You guys are actually one of our first teams to take us up on the workshop, which is really great. Yeah, and we're just excited about helping y'all understand our software, answering any questions that you have, and getting y'all set up and ready to go. So that's all I've got. Thank you, Peggy.
Awesome. Thank you very much, Jackie. All right, so I will also give a bit more background about myself. So during my undergraduate studies, I was actually a computer science student for the first 3 years, and then I changed my major into electrical to learn about the hardware. And with a bit backgrounds in both softwares and hardware, that make me really interested in embedded system, and which eventually lead me to an interest in learning PCB design. So PCB stands for printed circuit board. It's really the skills that could help you to transform that engineering ideas in your head into something that's tangible and you're able to apply to your engineering project. So about a couple of years ago, I was in a similar program, so I joined one of these workshops and trainings from Altium. And through the skills I learned from those workshops, it not only helps with my job search, my academic studies, it also makes me become more ambitious about my projects because now I'm able to do so much more to it. There's really not much to limit my imaginations at that point. So hopefully after this workshop, it's going to leave the same impression to you. And we have a lot of support resources here available. So we have posted a Discord link in the chat. And throughout the sessions, I'm going to start posting some of the link or important information that we've mentioned, or I might be answering a student's question, and you may want to keep a record of all those answers and links. So I will be sharing all those resources to this channel group, so the UTD 8 Hours Design 11/13/2025. And I think most people have already joined, and then you have seen that announcement here. So this course server is actually for the entire US. And before this workshop, I've only hosted workshops at UC Davis, and which makes it really exciting for me to host it here. It's my first time offering it off campus. And again, if you have any questions or feedbacks, I would be really appreciating it if you speak out about it during the session. So you can unmute yourself. This entire workshop is super casual, right? So you can unmute yourself, or if you prefer to type in the chat, you can type in the Zoom chat, or you can type in the Discord channel. So we have this question channels and those channels groups for you to ask questions. And if you want to start a discussion with your peers, for example, you may be asking your peers about, hey, what colors did you choose for the specific layer? Hey, how are you setting these rules over here? I just want to know. Or you want to post a screenshot of the PCB that you would design in this workshop. Then the discussion channel is for that purpose. And if everyone can just take a couple minutes to answer the polls in those channels, I would really appreciate it. That helps me to sort of get an understanding about the student groups here. Thank you, guys. And let me know if you do not have access to the Discord link. for students who finished, I'm going to introduce some other components that's on the server. So we have these channels for the workshop during the workshop. But after the workshop, let's say you're working on a club project, you're working on a senior design project, or even a personal project, and you're using Altium Designer for a PCB. And you might have a question that you cannot find an answer online, then you can feel free to post it in our community chat, community questions channels, and also the PCB showcase. Right, so this is where you can talk to the students from other universities who have also joined a similar Altium training and Altium workshop in the past. And I've only been hosting workshops for about a year, so later on we will start having more student groups joining this channel. Okay, so I guess the only rules on here is just not to post an announcement channel, because that's usually where I share the registration link. The registration links for the workshops, because I'm in charge of finding students from UC Davis, so just pay attention to, who these workshops are for. Right, so if this is a workshop just for UC Davis specifically, then you probably don't want to fill out those forms. Okay, yeah, but you're free to use all the community chat, PCB showcase, and community questions channels. Those are for everyone. Okay, so let's take a look at the results over here. So both students are from electrical engineering. Cool. Okay, do you guys have a senior design project on campus?
I do. I'm currently in senior design. Our project is involving creating a 4-in-1 speed controller.
Okay, so, cool.
Right now we're using KiCad because that's a little more user friendly, or at least like beginner friendly.
Yeah, definitely. I have a lot of friends who are using KiCad as well. It's an open source PCB design software. We have very similar features. And I think with a lot of backgrounds with other PCB design softwares, you would have an easier time to get started with Altium Designer as well. So that's cool that you have that experience. Okay, so that's great. Everyone has the experience to build a circuit on a breadboard. Awesome. Okay, cool. Yeah, so this workshop is totally beginner friendly. Okay, so I will be mentioning a lot of the vocabularies that are used in PCB design. And if I do not go in depth enough about those vocabularies, please speak out about it. I'm going to re-explain it, or maybe put out an example for us to understand it a little bit better. Right, so questions, feedbacks, please do not feel shy to unmute yourself to speak out about it or post in the chat. Actually, during my presentation, it might be a little bit easier for me to monitor the Zoom chat box rather than the Discord channel. So Discord may be for after the workshops, but during the workshops, I would still appreciate you to post the questions in the Zoom chat box. Okay, so does anyone have any question related to the Discord channels, or we're ready to move on? Nope, all thumbs up. Cool. So the next thing I want to talk about is the recording of this workshop. So I am currently recording, but these recordings, they're only for internal use. So we will not be sharing those recordings to the students, right? So if you need to take notes or anything, feel free to do so, but I will not be sharing the recordings with you guys. And I think another student just joined. So here is our attendance link. Please take attendance over here. This is how we can mark your participation. Okay, so I think that's enough about the logistics, and I'm going to get started with the slides of the workshop. Okay, so let's first take a look at the workshop title. It's called Altium Designer Workshop with Altium 365. So I work for a company called Altium, and the software that is developed by the Altium company is called Altium Designer. Yes, I can send you the Discord link again. There we go. Okay, cool. So Altium Designer is the PCB design softwares that people use to design their PCB. So PCB stands for printed circuit board, and we're going to look at a bunch of examples later on this workshop. And Altium 365 in the titles refers to a cloud-based platform. That is where it allows you to manage all your PCB design files and how you can share the files with your teammates, your project managers, and so on, or even your professors, right? So if you're familiar with programming, then you can think of Altium Designer Workshop as Visual Studio Code. That's where you can write your codes, modify your codes, manage your codes. And then you can think of Altium 365 as GitHub. So that's where you can share the codes and also where you can keep track of the history of your code. Okay. Or another examples would be Google Doc and Google Drive. So Google Doc is where you can modify your document. That is like Altium Designer. Versus Google Drive is like Altium 365. That's where you can store all of the different files, including Google Docs, Google Sheets, and so on. Okay, so that is what Altium Designer and Altium 365 is. Okay, moving on to the subtitle, we call this the Mastering the Fundamentals workshop. So what it means is we'll be covering the most fundamentals features that's available in Altium Designer. So that will be including how to start drawing the schematics. We call it schematic capture. It will also include how to convert your schematics into PCB. We call it PCB layout. And we will also learn about how to route all the wires in PCB and eventually generate fabrication files for you to submit to a PCB vendor. Therefore, you can order your PCBs and receive the board. Okay, so we will not be covering the ordering portion, but we'll be covering all of the features that is the bare minimums for us to draw a PCB using Altium Designer. There are a lot of other features you can explore, and I will be showing you just several more links for you to explore after this workshop. So hopefully this workshop could give you a well fundamentals to get started with those more advanced features. All right, do we have any question related to Altium Designer and Altium 365? All good? All right, thank you. Appreciate the feedback. All right, so here's the attendance link. I'm going to share a little bit later if I miss any student. And now let's go directly into the training agenda. So for today's training, it's going to take about 6 to 8 hours. It depends on how fast we're going with the participation session. So participation just means having you guys to actually join your own PCB in Altium Designer. And for how much existing knowledge do we need about PCB? You need 0. The only knowledge you need is knowing how to build the circuits on a breadboard. That's where we're going to start. Yes, this is the workshop for beginners. Yes, so no worries if you're not familiar with the terms I just mentioned, because we're going to go a little bit more in depth into explaining what they are. Okay, cool. So for training agendas, we're going to have a long break from 1 p.m. to 1:45 p.m. CT, Central Time, because I live in California, so my time may be a little bit different, which I think should be 11 a.m. my time. So if I did not stop at that time, please let me know. I think I have an alarm on my phone, but just in case. Okay, and other than that long break, we will have about 5 to 10 minutes break every hour throughout the session. So if I lose track of time, just keep talking. I like teaching. So if I forgot to give you guys a break, please speak out about it. Just say, Peggy, can we pause? And then I would just start firing an alarm to take a break. Okay. So throughout today's workshop, the first portions would be introduction to PCB. So I'll be using this set of slides to go over some of the fundamentals about terminologies in PCB design. Okay, and after that, bullet point 2 to bullet point 8, that would be the hands-on portion. So that's the time where I will be demonstrating how to, for example, drop down my components, and then you will be doing it in the next 5 minutes. And then I will be showing the next feature, and then you'll be using that feature for the next 5 minutes again. So that's the hands-on portion. Versus bullet point 1, this is just the introduction portion. All right, so let's try to read through all of the bullet points to see what we will experience today. So first, we will have the set of slides to go over some terminologies in PCB design. And then we'll get started with Altium Designer. We'll learn about how we can create a project and how we can create a project, especially on the Altium 365 platform. So later on, you're able to share this projects with your peers, and you can even view the projects through a web browser without having a full installation of Altium Designer, right? So you might have a PC that comes with Altium Designer application, and then you upload your projects to Altium 365. And then you might have a laptop that does not have installation of Altium Designer, but you can still view your project through a web browser on Altium 365. Okay, so we'll be doing that a little bit later. And after we've created projects, we're going to do schematic design. This is the portion where we'll be capturing the logic of the circuit. If you guys have experience doing SPICE simulation, so this is very similar. You're just dropping down the symbols and you're making the connections. That's all. And after that, we'll go over how to translate your schematic design into PCB layout. We'll use a tool, something called the engineering change order, which helps us to synchronize the design in the schematic and the design in PCB. So this is just a conversion step from schematic to PCB. And then after that, we will start the PCB layout. We'll be placing all the components on the PCB, and then we will also be routing all the components between those. We'll be routing all those components on the PCB. And after that, we'll go over a couple tools for us to validate our design. So they are the DRCs and ERC. ERC is electrical rule check, and that is for checking the schematic. And DRC is for checking the PCB layout. So that's design rule check. Okay, after validating the projects, everything looks fine. We're ready to start generating the fabrication files. So these are the Gerber files, the BOM files, bill of materials, and the pick and place files and NC drill files. Those are the files that you can submit to a PCB vendor for them to fabricate the PCB for you. And later on, I will show you how to look at all the files that we uploaded onto Altium 365, and also show you how to share your projects with your peers. And eventually we'll wrap up and have a Q&A sections towards the end. And the last things I would do in this workshop is to share you a feedback survey link. So please do not leave without taking that feedback survey. I would really appreciate your participation. Okay. Any question related to the training agenda? We're all good? Okay, cool. Am I speaking too fast? Should I slow down a little bit, or we're all good at this pace? Great, please? Okay, cool. Okay, so now let's move on to something that we are all familiar with, manually drawn logic diagrams, right? Because everyone here is an engineering major. I'm sure that you have seen some of the circuits, voltage divider, whatever, from a textbook, or maybe doing it in your homework, right? So those are just the logic connections between components, between the resistor, the capacitors, the power source, and so on. And we call them the manually draw logic diagrams. Okay, so usually the next step for us to bring the circuits to life is by using a breadboard, or sometimes we use a perf board. So those are the boards where you can solder the components onto the boards as well. So the breadboards that comes with these LEDs, and then these holes, and allows you to insert the legs from the components to form a circuit based on our manually drawn logic diagrams. And since everyone answered the polls, and it looks like we all have experience with working with the breadboard, so remember that when we're building a circuit on a breadboard, we have to insert components. We also have to make manual connections using these jumper wires over here. And how many of us have been frustrated about debugging their circuit because it's just so unstable and a lot of loosened wires? It becomes very difficult for us to ensure the integrities of the circuits, right? So this is what motivates people from converting their designs from a breadboard design into a PCB. That is because when you're building those circuits on the breadboard, it's not really scalable. So imagine you're starting a startup company, and then you just have this great product, and you have an order of 1,000, right? If that product contains a circuit board, that means you have to manually solder all those 1,000 boards, which becomes unrealistic. So having a PCB design, it will allow you to just draw a design using a software, and then you can produce as many as possible, as many as you want by submitting your orders to a PCB vendor. So this is how PCB overcomes the not scalable challenge for the breadboard design. And the next thing is building the circuits on a breadboard is not really reliable, because you can see that there are a lot of loosened wires, and the wires could age. Sometimes you will be making a modification of the other wires and you accidentally cut the other ones. And then, it's very easy to generate a short, right? Having a short, the whole circuits may just fry and stop function. So breadboard design is not really reliable for long-term use. And the next thing is also really time consuming. So imagine trying to debug these boards, and then you just have to look at the circuits, the actual breadboards, and sort of gain the logics in your head every single time you want to debug it. It's really hard to leave those test points for you to probe using your multimeters as well. So through PCB design, there are ways for you to leave test points such that it becomes much easier for you to probe using oscilloscopes or using a multimeter. And lastly, breadboard designs, they're error prone and detection is tedious. Right, so the same reasons, debugging is very challenging, and we do not have a very well-defined documentations for us to sort of help with debugging and also help with building the circuits as well. Okay, so moving on to the PCBs. So this is how we can overcome all the challenges that we just saw in the previous slide. So PCB stands for printed circuit board. The reason why it's called printed is because rather than making the connections manually using these jumper wires, those wires, they actually sit on the board. So they are printed on the board itself. That's why it's called printed circuit board. And after that, you can basically just solder all these components on top on the copper pads that we saw over here. Okay, so you might be wondering, what is the fabrication process of PCB? How can it replace, a regular breadboards or a regular perf board? Okay, so you can think of PCB as a huge capacitors because it comes with two conductive plates on the top side and the bottom side, and it comes with the dielectric layers in the middle. So usually this dielectric layer is made of epoxy resins and fiberglass, and the copper layers that's on top and the copper layers at the bottoms, they are in charge of transmitting the signals. So essentially what we do is, not what we do, the PCB vendors would do. They would use a process called etching, and you can think of it as like scratch art. So you might be defining where you want to place the wire, where you want to place the component, and then the etching process is going to scratch off the excessive coppers that are not needed for our design. Okay, so you can also think of this PCB as a sandwich. So it's just a sandwich with two components. Some of the components are conductive, some of the components are dielectric, and you always have this conductive, dielectric styles of stack up for this PCB. Okay, so the ones we're showing here, this is the simplest form. It only consists of two copper layers, but you can for sure add more copper layers in the middle. And we refer to the layers of the PCB by the number of copper layers. So you might have two copper layers and one dielectric layers. We still call this a two-layer PCB. And if you have three copper layers and two dielectrics to separate out those two, then we call it a three-layers PCB. Right? So we count the layers of PCB based on the number of copper layers that sit in the board. All right, so I'm going to pause for a couple minutes and see if anyone have any question related to the PCB structure. Nope, all good? Okay, cool. So moving on from this structure, conductive, non-conductive, conductive, non-conductive, on the topmost layers and the bottommost layer. Okay, I have a question. Why is the middle layer there again. Yes, so this is for insulating the signals from the top layer, insulating the signal from the top layer from the bottom layer. Right, so you can be routing signals from here to here on top, but you also want to route different wires from the bottom from here to here. So this would prevent it from shorting each other. Would these slides be made available? Unfortunately, I cannot share the slides. Okay, I will also not share the recording as well. Those are for internal use. Okay, cool. Yes, so coming back to the structure, other than having conductive layer, unconductive layer, and conductive layer, we also have layers for protecting these copper layers, right? So imagine you just finished your scratch art and you want to preserve it. Then you might be pouring over a layer of resin such that people cannot easily access those scratching layers again. So same thing for PCB. The reason why you see these green color is because those are resins in green color. And after we finish, or after the PCB went to have finished etching the copper layers of these board, they'll be pouring over a layer of resin, and they're in the green color to protect the structures on the copper layer. Okay, so we see these lines because of the etching process of the copper layer, but we also see this green color because we've poured over a resins on top of that copper layer. Okay, and the part that's exposed, the shiny part, they're just the exposed copper layers underneath the resin layer. So starting from the middle, we have dielectric, which is the yellow layers over here. And then we have the copper layer, which are the silver layer over here. And on top of that, we have the resin layer, which is the green layer over here. That is the very bare minimums of how a PCB is made of. Okay. All right, any other question? Okay, is the developed capacitance a concern? It is a very big concern, especially for high-speed applications or RF applications. They tend to be really, really finicky about, for example, the areas of the coppers they can place on the board and the length. So they may be doing phase matching and impedance matching. So the length of the wires that you put on the boards will also matter. Right, but for general purpose PCB, that's not too big of a concern. But when you're starting to design things like for drones, for RC car, that becomes a concern. Yes. Could you send a link to download Altium? Yes. Okay, over here. And that actually also raises another really good question is about the polygon pores. So polygon, that means a large areas coppers that we put on the board to make the connection a little bit easier. We will see that a little bit later. But if you put a really large area of coppers on top and you put another really large area of copper at the bottoms, then it will start really acting like a capacitor, which is not what we want, right? We want to minimize the capacitance, especially unwanted capacitance, the dielectrics. And that's something we want to prevent when we're designing the PCB. Okay, so I say that structure looks like a capacitor for PCB, but we do not want to turn it into a capacitor because that will screw up the integrity of the circuit. Okay, any other question? Nope. Okay, cool. So next I want to go over what is PCB design. So we just learn about what is PCB, then what are we doing as a designer for a PCB? So for us, we'll be using a software, something like KiCad or Altium Designer. We'll be using Altium Designer for this workshop. And our job is to determine the shape of the board and exactly where we want to place the components on the board. And lastly, we want to specify how we would like to connect those components. We call that process routing. So how we're routing those components by placing these wires over here on top. Right, so there are some other tools we can use, such as VIA. So VIA, you can think of it as a tunnel that helps you to transmit a signal from one layer to the other layer. So imagine it like a train going underground, and the signal is the train itself. So you can have via, which is the tunnel for the train to travel from one layer to another layer, or from one level to another level. Okay, so that's what we do as the PCB designer. And another really, really important job for us is to validate the integrity of the project, right? So you want to make sure you have connected all the components. You want to make sure this board is manufacturable, meaning that the PCB vendor might have some standards about the width of the wire or the size of the holes. You want to make sure the boards that you design meets the standards of the PCB vendor such that your board is manufacturable. That is also a very, very important aspect of becoming a PCB designer. Okay. All right. So now let's move on to look at the schematics. So the first step for us to start drawing a PCB is to first start from a schematic, the logical connections between all the components, right? So for people who have used spice simulation before, right? So in order for you to run a simulation, you have to first drop down all the symbols that comes with certain parameters, for example, the resistance of a component, the capacitance, the heat dissipation rate, and so on, right? So same thing here. At the schematic stage, this is where you will be picking the components based on the characteristics, the prototypes you might have built before you even started doing PCB design, right? So you might be already building a circuit on a breadboard to test your design to make sure the resistance is good, the capacitance is good, and then you're ready to move on to PCB design, right? So this is a step where for you to finalize the components you want to use for the project. And it also shows all the logical connections between the components. Advantage of using a software to draw the schematic is it comes with a lot of tools to help you to prevent you from making mistakes. So, for example, it helps you to check if you have any floating pins. So if you have any unconnected pins, it's going to generate a warning for you to double check if that pin is actually intended to be floated. Another thing is it also gives you information about the stock and the prices of these components. So this is a very unique feature offered by Altium Designer where you are able to directly look at the database of the component manufacturers and to get a real-time price and the stocks of that specific component. So that becomes really helpful when we're trying to budget the cost of the board. Okay, and another thing that you can do in Altium Designer as well is to create your own component and then link a real-life component with that component that you created. We will not be going over how to do it, but this is for sure one of the advanced features that you can explore after this workshop. And there's a very, very important concept that is presented in the schematic is net. So if you have never heard of net is basically a unique name that we assign to a signals on the board. So let's take a look at this component over here. You can think of this as the 3-pin header. And the 3-pin header might have one pin that's just dedicated to transmit a 5-volt signal, another pin that is dedicated to just transmit the ground signal. And we basically call this pin, it carries the 5-volt net. So the net is just a unique name that we assign to any conductive object on the schematic. Right, so this pin or this wire have the 5-volt net. This pin and this wire also has the 5-volt net. And this pin and this wire has the ground net. And this pin and this wire has the ground net as well. Right, so this is what helps us to check if we have made all of the connections necessary for a specific net, right? So you probably have a way to check if you have connected all of the power source for your projects or you have connected all of the grounds for your schematic and so on. And later we can see that these unique names could help us to access more features in Altium Designer as well. Okay, and lastly, I want to mention that all of the components that we place on the schematic must have a unique name. So we call them the dexinators. For example, this component over here has the name ULN, and this component over here has the name relay2. Oh, sorry, relay. And this component over here has the name relay2. This component over here has the name motor, right? So they all must have different names for us to uniquely identify the component. That also becomes very important because later, after you convert these changes into PCB, you want to have a way to call out the specific components you want. And if you have duplicated names for the same component, it becomes really hard to identify the components you want to place. Okay, let me pause real quick and see if anyone have any question related to schematics and net and Dexinator. All good? Okay, cool. Later we will review these concepts again. So you will be able to get sort of this reinforcement learning kind of feel for these terminologies. Okay, the next thing we'll do after we finish drawing the schematics is to convert it or import all the changes into our PCB, right? So the schematics, it only shows the logical connections. It has nothing to do with the physical placement of those components. And we do the physical placement in the PCB document. So the way this is going to go is we click several buttons for it to import all of the components into the PCB document, from the schematic document into the PCB document. And then we'll be placing those components onto the board and start routing it using these wires. So imagine what happens if we have a short. That is what the net comes in. If we have a short, that means two different wires with different nets, they have electrical connections. And that is unwanted because that's a short. So that is another way for the net or Altium designer to check the shorting problems through the net names in a design. And the idea about doing PCB layout is to figure out the most efficient ways to place all the components, right? So you probably want to place it such that you have the minimum distance between all the components, and you can also have the minimum length for all these wires. And we call these wires tracks, traces. They all mean the same thing. It's just different names for the same thing, right? So wires, tracks, traces. This is something that we probably want to minimize when we are designing the board. And the components too. So for example, you may already have a project in mind, and then you just need to fit this PCB into your project. It could be an RC car or a drone. And that sort of limits the shape and the size of the board. So it started becoming a challenge for the PCB designers to fit all the necessary components onto the board as well, right? So that is one design considerations when you're drawing the board. And another thing is you also want to make your board easy to read, right? So you could be placing just all of the resistors on one side or all of the capacitors on the other side, but it does not really give any visual information about the structure of your circuit. It probably makes more sense for you to group the components on the PCBs based on the functions, the logics, and the schematics, right? So for example, you might have an op-amps, you have a two-stage op-amps. So you may probably want to put the structures for the first stage on one side of the board, and then the components for the second stage of the op-amps on another board, on another side of the board. So that way you have a visual cues to help you to look at the circuits on the PCB. It also helps you with debugging. It's easier for you to find a test point to probe using multimeters and oscilloscope. Okay, let me pause here real quick and see if anyone has any question related to the process to go from schematic to PCB. Nope, all good? Okay, cool. So now I will start by mentioning some of the other design considerations you might have when you're drawing the PCB. So one of the questions have already been raised in the chat, which is the capacitance that you may be potentially developing if you have, for example, wires on top, and then the exact same wires at the bottom layers, right? So coming back to this picture, I may have a wire that goes from this corner of the board to this corner of the board. So it's literally right at the edge of the board. We might have another wires from the bottom layer that goes from here to here again. So that way it will start acting like a capacitor. And usually that's not wanted because it introduces noise, and it's not good for the integrity of the board. So the basic idea is when you're routing the 2 layers board, you want to minimize the overlapping areas of the copper from the top layers with the bottom layer, such that you can minimize the dielectrics developed when we're routing the board. And another thing we may want to consider is heat dissipation, right? So you might have a component that just dissipates a lot of heat. It might be a good idea for you to pick a component that might have a larger surface area. For example, you might have a resistor that carries a lot of current and high voltage. That means you probably want to pick a resistor with a bigger body. And the wires they're using to route that resistor should also have a wider width. Okay. Same thing for power connections and ground connections. You also want to make sure that the track width or the wire width for those specific signals would be a little bit wider compared to the regular signal wires over here, because that will help you to minimize the impedance and minimize the noise. Okay, so these are some of the things that you will get a little bit better at as you start drawing more boards. And later in the hands-on session, we will see how we can set the rules for those constraints and how it could help us to reduce the noise on the board. Okay, so I see no question in the chat, so I'm gonna keep moving. Okay, so let's go back to the questions that were just mentioned. You may already have a size of the board in your head, in your mind. And the components that we're most familiar with are through-hole components, meaning the ones that you can insert into breadboards to form a connection, right? But those components tend to be really big. So imagine you're trying to draw a PCB for a drone. It may be just the size of your palm or even smaller. It's probably not enough space to fit in all of the components you want for that specific PCBs. Then what should we do in that situation? Well, that gives a really, really good reasons for us to move on from using through-hole components to using surface mount components. So over here, I'm just showing you pictures between these 2 mounting technologies. The first one is the through-hole components. These are the ones that we use in the lab the most, and these are the ones that we can insert into the breadboards because they comes with these legs over here. But they also tend to be a little bit bigger compared to the surface mount components, which are the ones shown on the right-hand side over here. Okay, so I also have a picture here at the bottom that shows the size difference between the same resistor. So they have the same value, so this could be a 1K resistor through hole, and this could also be a 1K resistor, but using surface mount technology. Okay, so the difference between through hole and surface mount, first thing is their size. And second thing is the way that we mount the components onto the board. Right, so for the through-hole components, if you want to solder it onto the PCB, you have to make sure the PCB comes with 2 holes for us to insert the legs. And then you may be soldering those legs from the bottom side. Versus for the surface mount component, it does not require any holes on the PCB. It just needs 2 copper pads on top, and then you will have the component sits right on top of those 2 copper legs. And then you basically apply the solders to the side of the components for it to be mounted to the board, and you can start carrying the signals from the components down to the board again. Okay, so another terminologies. We usually call through-hole components by THD, so through-hole device, and the mounting technology through-hole T. Yes, so THT is the through-hole technology. So through-hole technology just means the through-hole mounting technology, and THD is the through-hole device. It's the device itself. And let's go to the surface mount part. So SMD, this is the surface mount device. So these are the components itself. The functions exactly the same as through-hole. They just have smaller size. And the way that we mount these through-hole components onto the boards, we call them surface mount technologies. So SMT. Right. So when you're picking the components in Altium Designer, you might be looking at some of the description. It says THT, THD, SMD, SMT. They just means through holes or surface mount. It's that simple. It tells you the way that you can use these components on the board. And other than having parameters, for example, resistance and capacitance, for surface mount components, it also comes with another very important parameter called package. So package is just a fancy name for the size of the component, right? So I may say this resistor over here, it has the package of 0204, sorry, 0402. So what does it mean? It just means the size of this resistor is 40 mil by 20 mil, and mil is just a thousandth of an inch. It's a length unit. Okay, so if you look at the surface mount components in Altium Designer, and you saw there's sections called package, that just means the size of the component. And all of these names you're seeing here, SOT, SOIC, BGA, they all tell something related to the package. It all tells something about the form factors and the size of this component. Okay, so maybe this is something you can watch out for when you're placing the components, because that's what helps you to determine if you have enough space to fit the specific components when you're dropping the components down to your schematic and to your PCB. All right, let me pause real quick and see if anyone has any question related to the mounting components. Nope. Also, right, so main takeaway, THT, THD, they refer to through-hole components. SMD, SMT, they refers to the surface mount component. These ones tend to be smaller. These ones tend to be bigger. And the next thing I want to mention is some of the pros and cons for using one from the other. Okay, so for the through-hole components, first, one of the cons is, of course, it's really big, but that also means they're much more stable because it would prompt you to have to insert the legs onto the board. It becomes harder to remove that component. So if you have something that you really, really want to sit there, for example, a power connector, then you probably want to use a through-hole component, right? Because you don't want the power connector to be easily removed from the board. And another advantage of through-hole component is you can actually easily mount it at home. So what it means if you have a soldering station and you just order the boards that comes with all of the through-hole components, those you could basically just use all of the components that you use to prototype your breadboard onto this PCB, right? So this is much easier for you to solder the components on your own onto the PCB, right? So which makes the through-hole components to be really beginner friendly, and also they're good for prototyping, right? Because those are something that you can basically do at home. Versus if you use the surface mount components, they come in really, really, really small size. And sorry, I think I just hit my microphone. And usually if you want to determine the size of the surface mount components, you usually use something called a reference ruler. Okay, let me turn this background off. Okay, so this is something you can easily get on Amazon. This is something I got from DigiKeys. But it comes with a lot of footprints for those components. So this could be one size for the resistor. This could be another size. This could be another size, right? So for you to get a sense of the package of this component using these kind of reference rulers. Okay, so if you're trying to determine the smallest possible components that can fit on your board, while not making it so small for you to not able to probe it, then the rulers becomes a really good tools for you to reference. Okay, and it also gives a reference tables for what each of these designators or these package names are referring to. Okay, so you may be wondering, okay, if I can already solder a through-hole components and it's so much easier to test and it's much more stable, why would I move on to the surface mount other than the reason for it being small? Okay, so a major reasons why most of the devices that we use in real life are using surface mount component is because it allows us to automate the process of soldering all the components onto the PCB. Okay, so imagine you're just opening up your PC, you saw the motherboard. Most components on there, they're actually surface mount technologies. And we as PCB designer, we're able to generate a file, we call it a pick and place files, that determines exactly the XY coordinate of where you want to place the components onto the board. So after the PCB vendor have received that pick and place file, they will put it into a machine called pick and place machine. And you can imagine it as like a machine comes with robotic arms that can quickly pick up the components and then place it onto the PCB. And they basically repeat that process for all the components, the surface mount component, and then they will use the oven to heat up the board, to heat up the solder paste that we apply to the legs of these boards to automatically solder all the components on your own, using the machine, right? So using surface mount component, this helps with mass production. If you want to spin out 1,000 boards, you don't want to use the through-hole components. You want to use most of your components as surface mount such that you can have the PCB vendor to solder all the components from you. And we literally just have to generate files to give instructions to the PCB vendor to basically perform that task. Okay, so another great point, through-hole components, they're good for small prototyping, small quantity, versus surface mount component, they're for mass productions, and they're for small surface areas on the board. Good. Cool. Did I just lose you guys? Are we going too fast? Or it's okay? Oh no. Okay, cool. Thank you. It's great. Okay, awesome. All right, thank you very much. Okay, so now we just finished going over the mounting technologies on the board. Next, we will finally get started with learning how we can use a software to basically perform all those tasks we just mentioned, right? So how we can drop down the wires, how we can put down the components, and how we can validate the project. Okay, so we do the PCB design using something we call ECAD. So ECAD stands for Electronic Computer Aided Design Tools. And Altium Designer is one of those tools. Okay, so here I'm just listing some of the features from Altium Designer. Right, so the first feature is unified and integrated platform. Okay, yeah, unified and integrated platform, which means that it's a software that's packaging a bunch of features for you to finish designing a PCB from schematic to fabrication output, right? You do not need to use one software for schematic, another software for PCB, and then another software for generating the fabrication files. Everything can be done in Altium Designer. And second is schematic capturing. So this is the step where we are drawing the logical connections, we're placing and picking the component for our circuit. So this is the step that looks similar to SPICE simulation. And ERC, electrical rule check, this is just the tools in Altium Designer to validate our schematic drawings. And we'll be using this tool later to check if we have any flaw on the board. Okay, the next thing is layout design. So this is where we can start laying out the PCB. So this is where we will start placing the components on the board and where we are actually establishing the physical connections using the traces, using the wires on the board. Okay, so this is the schematic and this is the PCB layout. So for PCB layout, it also comes with a tool to validate our design. We call it the DRC, design rule check. Right, so that could be something that's checking if we have an unwanted short or if we are putting two components too close to each other that violates its clearance. So clearance is another fancy word of saying the distance between two objects. Right, so if we place two things too close to each other, it might become challenging for us to start soldering, right? Because the physical parts may be colliding if we place the footprints for those two components too close to each other on the PCB. So these are some of the things DRCs would check. And another great features about the PCB layout document is it also gives us 3D view of the project. So we're able to look at the final product in Altium Designer directly. If the component you chose has a 3D body, right? So those are the step files. So if you're familiar with 3D printing, step file is just something that that specifies the volume of the component or the size, the dimension, the model of the components, basically. If you pick a component that comes with the models, then in 3D views, you will be able to look at the component. If you pick something that does not come with a model, then you would not be able to see the 3D bodies in 3D view of the PCB. In the projects, we have several components that comes with 3D bodies, several that does not. So we will get an experience of looking at the 3Ds and using the DRC. All right, the next feature is library creation. This is not something that we will go over in this workshop. This is a really useful features in Altium Designer. So you might be creating a libraries of the components you want, right? So you might have a libraries of resistors that come in different sizes. Right, so different sizes for through hole, different sizes for surface mount resistor, or you may even have a libraries of components, libraries of resistors that comes in different values. You have 2.2K, 1K, 10K, and so on. Okay, and you can basically get these libraries online. You can import those libraries and then use them in Altium Designer, or some of the libraries that are already available through Altium 365 as well. So Altium 365 not only manages our projects, it also manages the libraries, the component libraries that we will use for our project. Okay, so library creation is a very important feature in Altium Designer. Okay, next is simulation analysis. There is a way for us to perform SPICE simulations directly in Altium Designer, meaning that after you finish drawing the schematic, you can run a tool to validate your projects and analyze your circuit. We will also not go over how to do this in the workshop, but if you're interested, I can post you several links on how to do it for you to explore after the workshop. Next feature is fabrication and assembly output generation. Okay, so the fabrication and assembly files, they're basically files that you can send to your teammates, to your professor, project manager, or the PCB vendor for them to understand your design and be able to fabricate your PCB. Okay, so for fabrication output, that could be the Gerber files, the NC drill files, and the pick and place files. And don't worry about that. We're going to look at an example of all those files later, and you'll be creating those files as well. Okay, but those are the most fundamental files that you have to share with the PCB vendors for them to understand your design and start fabricating your PCB using their machine. Versus for the assembly files, so these are the files for you to explain the designs. For example, you may be specifying the size of the board in those documents, and you also want to leave some notes telling the person, your teammates, is person who's going to solder the board, some things they have to watch out for. So for example, you might leave a note, something like, hey, solder this component at exactly this rotation. Hey, pay attention to the destinator. This is the pin 1 of the specific components. You have to mount it certain ways. Right, so assembly is for soldering or putting together the board, versus fabrication is for actually manufacturing the board. And we will look at how to generate assembly files as well. Okay, the next feature is documentation. So documentation, this is another way for us to come up with some assembly files as well. So this is where we can have several sheets of PDFs to specify, for example, the design of the board, the materials that are used in the board, and the layers stack up. So how many copper layers do we have, and how many dielectrics layers do we have, and what type of materials should we be using for those specific layers? Right, so those are some of the documentations that we can put down in the draftsman's file, and we will also be creating the draftsman files today. And lastly, data management and collaboration. This is closely related to the Altium 365 cloud platform I just mentioned, right? So Altium 365, that is like the GitHub for Visual Studio Code. For data management, you can upload all of your projects onto Altium 365. You can view all your projects on Altium 365. You can also send a share link to your teammates for them to collaborate on the same projects through Altium 365. One thing I want to mention is you cannot edit your files on Altium 365. It's just a viewing. To edit any documents, you have to install a copy of Altium Designer, pull the projects from Altium 365 down to Altium Designer, and then modify the files there. Okay, so that's how you can use Altium Designer to do data management and collection. All right, let me pause here real quick and see if we have any question related to these features. So the ones that will explore the most, we'll explore everything except for 0.4 and 0.5. All right, awesome. If that sounds good, let's actually take a 5 minutes break because it's been an hour. And I will set a timer here. If you pick the right component, then all of these parameters will be inherited into that component description Excel sheet. And it just becomes much easier for you to create the sheets versus you have to type down every single parameters and check them at the stage of generating the file. So you want to plan ahead at the schematic stage. Okay, cool. That's 5 minutes. Okay, ready to move on? Any other question? Okay, hopefully everyone has to take attendance. And now let's move on to the last 2 slides. Okay, so we just went over some of the features in Altium Designer. We also look at the different components we can use. And we look at the design workflows from coming to schematic to PCB. We also look at some of the design considerations we have to think about. For example, the unwanted capacitance, the dielectrics. And because of the size, we need to place these components very efficiently. And because we want it to be easily debugged and we want to minimize the impedance, we want to minimize the length of these wires as well. Okay. So next we will look at the entire design workflows in Altium Designer. So exactly how can we start from the installation of Altium Designer all the way to the fabrication output. So these pictures, it might look a little bit intimidating, but trust me, after this workshop, you will get new level of understandings of every single steps listed over here, because this is the templates we'll follow in the hands-on portion, right? We will be walking through how to do all of the steps after this presentation. Okay, so we separate the diagrams into 2 different sections. We have the schematic workflows and also the PCB workflow. For the schematic workflow, remember schematic is just for us to draw the logical connections of the circuit. It's the thing that looks like SPICE simulation. And in order to do that, the first thing we should do is to install Altium Designer. So you need to log into your account, you need to connect to your Altium 365 workspace, which helps you to do version control, keep track of the history of your changes. And then we can start creating new projects. And a project is just a package of different documents. It's a package of schematic document, PCB document, fabrication document, draftments files, and so on, right? You can think of it as a folder to store everything related to a project. And after that, we need to look at how to set up the environment, right? So we probably want to change the style of our cursor, change some of the preferences, so it makes the design process a little bit easier for us. And next, we can start component placement. So for part placement, this is where we will be selecting the component from the components panels and the manufacturing part search panels. And this is the part where we need to pay attention to, for example, the resistance, so basically the values of the component, the size of the component, and if the components even come with a footprint. So footprint is something that we place on a PCB, right? So if it doesn't come with footprint, it's probably not going to be a lot of use for us unless we're going to draw the footprints for the components on our own, which is not something we're going to do in this workshop. That is more advanced, right? But taking the components and then dropping it onto the board. This is, sorry, not on the board, on the schematic sheet. This is what we're going to be doing at this step. After we place all the components, we're ready to start wiring all the component. So even at the wiring stage, you may be sort of adjusting the location of the part so it makes the schematics easier to read. Right, so coming back to the two-stage op-amp example, you probably don't want to put all the op-amps at one corner and the resistor on the other corners, right? You want to make sure that you place all the components for the first stage on one side of the schematic sheet and the components for the second stage of the op-amps on this another side of your schematic sheet. So you can sort of consider these two steps as something you do simultaneously. Okay, and after that, we need to add annotation. Right, so coming back to the schematics, we want to make sure all the components come with a unique name. And we call the name of the component as destinator. Right, destinator is another fancy name for the name that we assign to a component. Okay, and annotation, we will show you a tool in Altium Designer that will help you to automatically assign the destinators to all those components. So R1, R2, R3, and so on. You do not have to manually type in those names when you're putting down the component. There is a tool for us to do that. Okay, after annotations, we will do ERC, electrical rule check. Right, so this is a tool that could help us to check the design in the schematic. Do we have a duplicated destinator? Do we have a short on the wires? Do we accidentally leave a pin floating? Right, do we have a floating pins? Or do we have any driving source for all of the input pins? Okay, so those are the things that ERC is going to check. Moving on from that, you might probably want to add some documentations on our schematics as well, right? So for the person because the person who's drawing the schematics may not be the person who's doing the PCB design, right? So if you're someone who's in charge of only drawing the schematics, you probably want to leave some notes in our schematic sheets for the person who are doing the PCB design, the PCB layout, to gain a better understanding of your circuits and be able to have an easier time to do the PCB layout, right? So these are some of the notes that you can put on the schematic sheet. And lastly, for the schematic workflows, we will just package all of the changes in schematic and then import those changes into PCB. So this is the last step. EOC stands for Engineering Change Order. It's a tool in Altium Designer that helps synchronizing your schematic files with your PCB files. Okay, so think of it as this way. So when you're dropping down the components in the schematics, you're not dropping down the components in the PCB, right? So the changes there are only locally on the schematic. And for it to import all of those components and net names and destinators into the PCB document, you need to fire up this engineering change order for it to actually bring the footprints into PCB, to actually bring the net connections into the PCB. And those are the things you specify in schematic. Okay, so this is the synchronization tool. This is what transfer the information from schematic into PCB. Okay, I'm gonna pause real quick and see if anyone has any questions related to schematic workflow. Nope. Awesome. Cool. Now let's move on to the PCB workflow. So this is at the step where we just finished importing all of the components, all the nets, everything, informations into the PCB. And then we can start by first defining the shape of the board. So board outline, right? So you might already have idea about where you want to fit this PCB. So you probably already have a dimension in head. You want this PCB to be exactly 2 centimeters by 2 centimeters. And then you probably want to start specifying those board shape first. And then you look at the space you have available and then start placing the components onto the board. Okay, so the first step we're going to do is just to specify the shape of the board. The next thing is for us to explore the stack up So stack up, another fancy name of something very simple. It just specifies the structure of the PCB, right? So this, you can think of this as a stack up of the PCB. So stack up information about the layers and the layer materials, right? So the stack up for this board, it could be a copper layer, a dielectric layer, and then another copper layer. That's how simple stack up is. You can think of it as the recipe of a sandwich, right? So stack up is just a recipe for the PCB. It shows how we would like to stack all of those layers up. Okay. We'll only look at this tool. We will not be adding more layers, right? This is just for future explorations. But we will still be looking at how we can add more layers or how to modify the layers and so on. Okay. Moving on from that, we have defined the shape of the board. We have defined how many copper layers and dielectric layers we want on the board. Now we want to define exactly how wide we want those wires to be, exactly how far apart we want the components to be placed next to each other. Right, so we want to set some design rules that helps Altium designer to eventually check. So DRC. So DRC is what checks our PCB design. And DRC is checking the PCB design based on the rules that we set in design rule steps. Okay, so I will be sharing you with several manufacturing capabilities from different vendors. So they are Oshpark, PCBWay, and JLC PCB. Those are the companies where you can upload the fabrication files for them to actually fabricate the PCB. And they have really, really strict rules about the things they can fabricate. For example, they cannot drill a hole that's smaller than 2 mil. And therefore, you want to prevent yourself from placing any holes that's less than 2 mil. And that's where we can specify. That's what we can specify in the design rule step, right? We specify Altium designer, hey, let me know if I'm violating all these manufacturing capabilities. Okay. And those are everything that helps us to prepare for PCB layout. Now we can start with actually drawing the PCB. Okay, so similar to schematic, we start with placing all the parts onto the board. Right, we look at how much areas we have available, and then we start placing the components onto the board. And sometimes this is where you want to consider maybe enlarging the board, or you probably want to pick a smaller components as well, right? So there are some chances for you to go back and forth between schematics and PCB or from part placement to board outline. This is very normal. Okay, after placing the part, we want to start making the connections. Making the connections between the parts in PCB, we call it routing. And sometimes people even call the wires, so we have names for it, traces, tracks. We also call them routes. So that's just another name for wires as well. They all mean the same thing. It's just a path for us to conduct a signal. That's all. Or transmit a signal. Okay, so routing is the process for us to place down the wires on the PCB. The next thing is polygon pour. So polygon pour, the noun here is polygon. So polygon just means a large areas of copper. This is very commonly used when we're making connections between ground pins and between VCC pins. Because for these pins, we want to minimize the impedance and the noise, which means that we need to have more conductive areas. We want to make sure the wires that connects those pins, they're really wide. Okay, so using polygon pour, this is one technique for you to make connections between those pins with minimum noise. But also, coming back to the question about the capacitance, there is a very, very high chance for us to develop a large dielectrics, highly unvaulted capacitance when we're drawing down the polygon pours. For our specific projects for this workshop, it's not that big of a concern. But if you're starting to draw any high-speed applications or, very finicky designs with EMFs, then you want to start paying attention when you're drawing down the polygons. So we will go over how to place the polygons, but it's up for you to explore in what situations you need to be careful about placing these polygons. Okay, so these 3 steps, they just covers how to do all the layouts. And after that, we can do document creations. I usually like to do document creation after the DRC, but essentially the document creations is where we can create assembly documentations, right? We'll be telling people, hey, this is where I want to place these components and you have to mount it in a specific orientation. You have to pay attention to, the parts number that you're ordering for this part specifically because I want it in this specific form factor, and so on. Right? So documentation and creation, this is where you can specify some of the rules you want to tell to other engineers in your team. And next, we do DRC, design rule check. We have ERC to check schematics with DRC to check the PCB. Right? So this is where it checks for the short. You want to make sure two wires with the different net, they must not collide with each other. They cannot conflict. Otherwise, it's a short. And it also checks if I'm placing any holes, vias, right? So vias, they're holes. Remember, that's the tunnels that brings the signal from one layer to the other layers. Want to make sure the via is not too small, such that it's not even manufacturable. Also want to make sure that I'm placing enough space between any two components or any two objects, right? Such that when I'm soldering those components, it will not be colliding with each other. Right? So for example, you may be putting down two connectors, and those two connectors, they cannot be too close to each other. Otherwise, the plastic part of the connector you're going to solder down to the PCB would prevent you from soldering down because those two components are colliding. Right, so those are some of the things the DRC can check. And lastly, if you pass off the DRC, then we can do the fabrication output. This is where we generate the Gerber files, the NC drill files, the BOM files, the pick and place files, and so on, for you to order the board and for you to share with your teammates. All right, that is the entire workflow. Any question related to the PCB workflow? Nope, all good? Okay, cool. We'll get a much better understanding on those workflows later when we're on the hands-on portion, which should be in about 15 minutes. This is the last slides I have for the first bullet point. Okay, so lastly, I just want to talk about some features you can do or availables through Altium 365, right? So coming back to analogies, Altium 365 is like the Google Drive, and Altium Designer is like Google Doc. You modify your files on Altium Designer, and you manage, store, and share all your files on Altium 365. Okay, so in Altium 365, it allows us to store all of our PCB design. It also allows us to leave a comment on the design and share with the web, right? So, for example, you're doing a class project or senior design, and you want someone else, your professor, to review your design. Then instead of packaging all of the documents and then send them a zip folder and then they have to download Altium Designer to open up the zip folder, it could be much more simpler by just uploading the files to Altium 365, and then you can share them with a share link through email. And they can directly view the projects on a web browser. Okay, so Altium 365 helps with design reviews and sharing on the web. And for anyone who has access to your project, they could also leave a comment for your project as well. So think of commenting in Google Docs as well. You can sort of highlight some part and then leave a comment, something like, you probably want to consider using a bigger part for this, or you probably want to check this part of the design, and so on. So this is a really good ways to share with your teammates or professors and have them to comment your design to make suggestions. Okay, so the next features in Altium 365 is mechanical design. This is still, I think, a semi-new feature. I've never used it before, but there is a way to use Altium 365 to collaborate with the mechanical teams. So those are the people who are doing designs in, for example, Fusion's 360 or Maya, and so on. We will not explore this feature, but if you're interested, this is something you can look at. If you also have a mechanical team, for your project. Okay, next feature is centralized cloud storage. So, it's a cloud storage. It does not take up the space on your local computer. Unless you want to make modification, then you have to make a local copy on your computer. But other than that, all the components you want to upload there, the template files, the schematic file, PCB files, draftman's files, pick and place, Gerber files, whatever files you want to store on clouds, you're able to upload them to Altium 365. So it acts as a centralized cloud storage. And next, libraries and supply chain. So going back to the library creations, again, you can create a libraries of components on Altium 365 and then basically pull out the components from that specific libraries every time you're drawing the schematic, right? So this is a way to help to help you to keep the consistencies across different projects, right? Because the components you put in the libraries, they're likely to be the components that have already verified, have tested that they all worked, right? So if you want to reuse them, it's probably a good idea to create the libraries in Altium 365. So every time you want to use it, you just pull it out from the workspace. Okay, next, teamwork. This is similar to what we just mentioned earlier. You can share the links. You can have multiple people comment on your project. And in fact, you can also have multiple people working on the projects at the same time. You'll be able to see other people who are also currently on the same projects on the same workspace. And yeah, it's going to show a little profile pictures while you're modifying the files in Altium Designer. So this is also something you can explore when you're working on a group projects using Altium Designer. And lastly, manufacturing. You can store the fabrication files up to Altium Designer. And you might have different fabrication Altium 365. You can also store fabrication files for different versions on Altium 365 too. So there's a version control system on Altium 365. You might have a board for version 1, and you might be generating all of the fabrication files for that specific version. And then you'll be moving on to version 2. But the copy of version 1 fabrication file is still stored on Altium Designer, Altium 365. Okay, so you can be moving on to different stages for projects, but still have access to all of the manufacturing information, fabrication files from the previous version. Okay, so that also becomes a really convenient and useful ways for us to use Altium 365 to manage the project. All right, so do we have any questions related to Altium 365? We'll be looking at a lot of these features on the hands-on portion. Nope. Awesome. Cool. All right. So hopefully through the hands-on portion, it might help you to clear up some of the confusions you might have gained in this presentation. And I can always come back to the slides if you want me to explain them a little bit further. Okay. So starting from now, we're going to start drawing our practice project for this workshop. And it's going to be a light sequencer, or I think sometimes people call it the LED sequencer. I will go over the schematic a little bit later, but at first I want everyone to start launching their Altium Designer application so I can walk you through the step of setting up the design environment. And in fact, I want to take a screenshot of this guy, and throughout the workshop, we'll be working through it and then start crossing out these boxes. Okay. For the hands-on portions, I will tell you exactly when to follow me and when for you to just sit back and listen. I will give you more time to do it later. So at the beginning, I do want you to follow what I do here. So please first launch Altium Designer. Okay, so I'm assuming that everyone has already finished installing Altium Designer. I'm going to cross this guy out. And now we're at the stage of creating a new project. Oh, by the way, there's one thing I forgot to mention. If you're already using a copy of Altium Designer for a different project, and you do not want to change all the preferences and the settings for that specific project, then it might be a good idea for you to download a different copy of Altium Designer, right? You may have some projects already used for some other clubs, and you don't want to mess up the settings for that project. Then, okay, I'm going to run the installer again so you can see what I'm talking about. Okay, so this is the installer, right? If you want to download a different copy of Altium Designer, that just means another Altium Designer, but you can have different preferences settings, different projects open up, and it does not affect the previous copy you already have. So at this step, just check New Installation and select Next. And it's going to ask you to sign in and then store the files in 2 different folders. Just create 2 folders on your desktop or whatever, wherever you want to store this copy of Altium Designer. And then you'll be able to get a fresh copy of Altium Designer to follow what I'm doing here. Because the one I'm using, it's also a fresh copy. So, yeah, if you're using a copy from a different project and you want to have other copy that's not affects the previous copy, then this is how you can do it. Okay. So everyone has their Altium Designer launched? All good? Okay, awesome. I need to get my chat box back. I don't want to miss any question. Okay, cool. So the first thing we're going to do here is to log in. So to log into our account, you want to first go to this little profile icon in the top left corner. And then if you're not already signed in, you probably need to click on several buttons and then it will prompt you to sign in. So I'm going to have you to do that for about 30 seconds. So make sure you have logged in. Oh, and by the way, I guess a better way of following this workshop is to have 2 screens, and then you have one screen for doing the design and another screen watching me what I'm doing. Right? It could be your laptops and your phone or whatever. Yeah. But that might be easier than switching back and forth. Okay, so after we have logged in, we come back to Altium Designer and then click on the profile again and click on licenses. So this is going to bring up the license management page. For you, you should see an Altium Designer Professional. And then let me release this license real quick. Yes, something that looks similar to this. So for Altium Designer Viewer, this is the license you can use when you do not have a license. It only allows you to look at the projects, but it does not allow you to modify the project. This is for the Altium Designer Professional. This is the license that allows you to modify the project. Okay, so you want to click on Use License. And you should see a green box here that says In Use. If you have another copy of Altium Designer opened and then that copy might be holding the license, then you can just click on the seat and then click on that license and then click on Release. That will force the license to be released from the other applications. And then you can basically use it for your current application. Okay. So, assuming that everyone already has their license, come back to this homepage. This is something I want to share with you about the extra features that you can explore after this workshop. So, for a lot of notable over here, if you're, for example, you just walk through this workshop, but you probably don't use Altium Designer for about 2-3 months and you forget about some of the features that I've mentioned, then you can come to this Discover tab, and these are basically the steps that we'll be going over in this workshop. So you want to have a quick refresh about the contents we've covered in this workshop. You can come to Discover and then walk through these steps over here as many times as you want. Okay, so they come with the documentation. If you click on it, it will bring you to a web browser, and then it shows you all the screenshots, all the steps that you can take to perform certain tasks, right? So all the steps over here, they are similar to these steps over here that were shown. Okay, so in case you need to refresh your memory, this is a good place to start. For more advanced features, you can also go to Learning Center. So this is where you can learn about features that are not covered in this workshop. And I'm sure you can also find YouTube videos online to learn about these topics. Yeah, but you know, uh, look for the topics you're interested in and then just dive deep into it. So, for example, this is a pretty interesting one. It helps you to do rigid flex PCB design. Um, there should be another video that talks about how to do simulations, right? Mixed simulation series. So if you're interested, these resources, they're also available to you. Okay, and yeah, so those are the two things I want to mention on this page. After we have gained a license and log into Altium Designer, the next things that we want to do is to connect your Altium Designer with your Altium 365 workspace. Okay, so to make the connections, you click on the Not Connected buttons next to this profile icon, and then select, it should say your names and then workspace. If you have not activated your workspace before, it would just prompt you to activate it. So this is a good time for you to activate it. But for people who already have a workspace, you can basically click on your personal workspace. Okay, so I will give a couple minutes for people to basically finish what I just said and explore this page. I'm gonna start a timer.
Okay, I got a bunch of requests for
Mhm.
the live thing, so I'll try to handle that right now for anyone who just sent that request.
Okay. Oh, do you mean when activating the workspace?
Yes.
Okay, cool. Yeah, I remember that could take a bit. Let me actually make it a little bit longer. Let's give 4 minutes. Yep. That should be enough time to activate the workspace and explore, or for people who already have the workspace to explore these features over here. I'm going to post a poll on Discord to see if people need more time on this step.
Oh, it's giving me an error when I try to approve them. Oh, no, it worked now. Okay.
It is okay. Also, yes, because if there's an error, I have to contact the coordinator, Jackie. Yeah, which should not be a problem, but I need to know immediately if there's any problem we cannot solve here. Yeah, but thanks for letting me know. Okay, so need more time. Explore Learning Center. Let Altium places fine. And license. Okay, so I just post a poll on Discord. And if you finish exploring, you don't need more time, then you can just press no. It helps me to get a sense of how much time I should give to the students. And I will do that to every steps. So it's this poll over here.
Oh, migrate.
5 more seconds. Okay. So everyone has access to their workspace, or we need a couple more minutes. Saw 8 people answer the poll. Okay, let's give a couple more minutes. Because this is a really important step. Without this, we won't be able to move on to the next. Oh, sorry. Several people posted in the chat. Let's see. Are any of the trainings on this Altium website similar to today's session? The things mentioned in Discover, it's very similar. But it's not using the exact same project though. I'm only using a project because this is easier for me to make my points. It's also created specifically for this workshop. Yeah, but the skills, they're all the same. Okay. My workspace still isn't activated. Okay. Did you fix that problem, Mahi? Do you need more time, or do you think that's something I should contact the coordinator? Okay, I will go to the next question. Looks like you might need to restart Altium Designer for it. Yeah, let's try doing that. Okay, cool. Okay, awesome. Yeah, I'm not sure if it's a good idea to do it on your Comet Robotics workspace. If it's fine for the organization, it's totally fine. Yeah, but if you want to look at how to use your personal workspace, we can also do that too. But the idea is you have to have a workspace. Okay, I'm concerned that not everyone will be able to access Designer. We only have 10 seats available. Yeah, so you probably want to... Oh, not everyone has a license?
Well, it should. We should have enough. But I don't. Okay. Oh, I think I can fix that issue really quick. Hold up.
Okay.
Because it was. I was going sort of blind on how to do this. Check it now. Maybe reload. When I was initially setting up like licenses, I was so confused, and I think I like cut down the licenses for the thing I put everyone in. But it should be fine now. Push it up to 150.
Okay.
Yeah. Okay, good.
Okay, cool. Thank you, Anna.
Okay.
The only workspace options you have is Comet Robotics option. Does yours say something like add a workspace? Like there should be a button. So it should show shared with me, and then it shows the Comet's workspace. And then I think there should be because each individual Altium Designer account should have a personal workspace. In my case, my nickname is Peggy, so it says Peggy's workspace. But if you do not see this, there should be a button that says activate my workspace, and then that should prompt you several steps to do that. Or if, actually we're on Zoom, I always forget about that. If you want to share your screen, can I take a look at your screen? If that's possible. Okay, so you should have right to share your screen now.
Okay. Wait. So this is what I see. I go to home. But there's no.
Okay, let's try clicking on My Altium 365. See what it does.
Oh.
Okay, can you go to Project?
Huh?
Can you go to the Projects tab on the left-hand side? Okay, cool. This is still the comics robotics. Okay, that's very interesting. It might be a license issue, but that should be fine. Are you okay? Are you okay with people uploading all those folders onto this workspace?
I think what we should just do is just make a folder.
Create a new folder?
Put everything in there.
Exactly.
Workshop.
And mhm. Exactly.
There you go.
Yeah, that's perfect. Okay. I would keep that in mind and notify you guys how to store the projects in that folder. Yeah, I'm not sure it allows us to create a personal workspace. Okay. Okay, I see. Yeah, thank you for that clarification. If that's the case, then just click on the comments robotics. Okay, I think for your case, it should say comments robotics workspace, but to me, it says Peggy's workspace. But the whole idea is you have to be connected to a workspace and you also have to activate your license. Okay. And if we were clear on those parts, please answer the poll so I can make sure everyone has a good environments to get started. We'll put a 3 minutes timer on that. Are you guys a club organizations or what is Comet Robotics?
What is it?
What is Comet Robotics?
Oh, it's the name of our club. So.
It's a club. Also. So my workspace is Project Group 1. Your workspace should say Comet Robotics from this menu. So after clicking on this button, do you see a workspace that's called Comet Robotics? If you do, just click on that workspace. How do you get to the workspaces? Are you logged into your account? Or Michael, if you would like, you can also share your screen. I can walk you through the process. Okay, cool. So it's a request issue. So what are some of the projects you guys built in this club?
So in the Comet Robotics organization, we have a couple. We have our Solis rover project, where they design like a Mars rover sort of thing.
Whoa.
And we have Combat, which they make like. Have you ever seen like combat bots that go up against each other? We also have like Comet RX, where they design PCBs for that combat. So we have like a lot of different sort of projects going on, from like Mars rovers to Vex, VexU, to what was the other one? Chessbots, which uses a lot of PCBs. So we're expanding a lot into like embedded systems. That's why we did that.
That sounds exciting. Yeah. And by the way, if you guys later on run into any questions related to, the workshop materials or just Altium Designer in general, feel free to post your questions in the community questions and community chat channels. I think a lot of other people will be willing to help, and also it will be a learning experience for me as well, because you guys are doing so many cool projects. Only if they're open source, right? If they're not, don't share them. Okay. Let's check Discord. Okay, so we have 10 people voted. I think we have 5 more participants. They're still having trouble with the step. Okay, do you guys all receive an invitation to the workspace? Okay. Okay, so since 11 students said yes, I'm going to assume we're all good. And the next thing we want to do is well, my original plan is to start creating a project right now. But actually, let's start looking at Altium 365 real quick, because we have to create a folder for us to store the project. So let's go to our workspace. So you come back to this button, and then next to your workspace, you should see a little globe icon. So click on that globe icon. Which should help you to access your workspace through a web browser. Okay, so after you have, sorry, this is the part I want you to follow me. So after you have opened up this workspace, navigate to the projects tab on the left-hand side. You should also see the workspace name over here on top. Okay, so click on projects. I think you guys should see a folder that comes with the Altium stuff folder. I would just assume this is my Altium stuff folder. And I want everyone to start creating a folder for yourself, right? So after you open up that folders, you want to store all of the Altium Designer related projects. And then click on this new button. And then select folder. So give this a name. So I'm gonna call it Altium Workshop Peggy. Something like that. And then description could be my LED sequencer project for Altium Workshop.
Just to be clear for everyone, for us, go in the Altium Workshop folder. So don't do it in like the base folder, toss it in the Altium Workshop folder.
Yeah. And then we can click on create to create that folders for us. And over here, you can also see the folder path. So make sure you go to the Altium folders that Anna just created. Sorry, am I mispronouncing your name?
No, you're doing good.
Yeah. Okay, awesome. Thank you. Okay, I will wait for everyone to do this real quick. Yeah, and if you want to check if everyone has created the folders at the right place, because I don't want to mess up your folder as well.
You're okay. Everyone's doing great.
Awesome, thank you.
I think, what is that? 12, 13 folders in there right now?
Awesome, cool.
Oh, Anna, I need help.
And you guys can feel free to share your screen to get help too, if that helps. Yeah, I should give permission for everyone to share their screen.
Yeah.
Okay, let me post another poll on Discord.
Wait, Anna, I'm in the workspace. Where do I go now?
Can you send a screenshot in the discussion in the Discord thing?
Well, I guess I can. One sec. Well, okay.
Cool. If you're at that step, you want to click on this button on top. It says Connect Robotics at, oh, sorry, Comet Robotics at UT Dallas. And then you should see a globe icon next to that entry.
Oh, the globe.
That says Open Workspace and Web Browser.
Wow, I see.
Yeah, this is super handy to have.
So Altium Workshop. Ah, nice.
So I will set another timer for a couple minutes. And after that, we will move on. And I guess for students who are on here already, you might already have several, I think, sample projects. You can just look at them without modifying them. And then there are actually a lot of features you can, or a lot of things you can look at simply on here. And I will go over all these features next. So just in case if you want to spend the time on exploring Altium 365. Ten more seconds. Okay, cool. Now let's move on to sort of explore the features on Altium 365 a little bit. This is a time for you to sit back and just listen to my presentation. And later I will give you some time to explore all the sections here. Okay, so for this part, you can just sit back and listen. Okay, so we have just created that folder on our workspace, but now I want to sort of show you how you can view the projects on Altium 365 and how you can view them. So I already have a project created on Altium 365, and this is actually the project we'll be creating for this workshop. So this is an LED sequencer. Right, so going back to the project scenario again, we always have schematics and PCB. So this is schematic, and this is the PCB for that LED sequencer. And the idea of this LED sequencer is we want to have 10 different LEDs, and these LEDs will light up one after the other. So the time that this one lights up, everything else is off. And at the time that this one lights up, everything else is off. And it will just be lighting it up in the sequence. And the way that we control the LEDs that will be lighted up is by using this chip. So this is a counter, and it's a counter with only 10 outputs. right? So you can see that from pin 0 to pin 9, or if you look at the actual pin number assigned on the right-hand side, pin 3 to pin 11. So these are the pins that will only have one line to go high at a time. Okay, so this is a counter that counts from 0 to 10, and every time it changes or increments the number, it would just be putting the next line high and leaving all of the others low. So you can think of it as a register, that can only count up to 10. This is basically what this chip is for. So the way for us to control the frequency of this counter is by using this 555 timer. So 555 timer is a very common parts that we use in the project to control the timings for the component. So you can think of this 555 timer, it just generates one output, and that output is a square wave. And every time you finish one cycle of the square wave, this counter will increment by 1. And of course, that's probably not exactly how this works, but that's the idea. Every time you have one pulse coming out from here to here, this component will start increment by 1. Okay, so this is the clock source, and this is the counter. Okay, so moving on, there is a way for us to control the frequency of this timer, and you have to read the data sheet of this 555 timer made by Texas Instruments to understand exactly how it's going to change the frequency. But the idea is you can basically change it by changing the resistance of the signals you're connecting with this pin here and this pin over here. That's what this potentiometer is for. So potentiometer is just a component that you can use to adjust the resistance by switching a knob. Okay, so if you think of the knobs that the DJs use, rather than turning up and turning down the volume, so you're turning up and turning down the resistance. Okay, so this is what a potentiometer is. And we also have some resistance and capacitor over here just to minimize the noise and then also control other specs of this 555 timers. But you will be determining exactly what resistor to place and the values of those resistors by reading the data sheet of this guy. So we'll be providing you with all the values, all the components you have to add to the schematic. But I just want to walk through this schematic to give you a sense of the project we'll be building. Okay, so after the 555 timers, we have to have sort of a way to power up all the chips. So we have to have an external source connector. So this is just a 2-pin connector that would basically fit in a VCC signals and a ground signal. Okay, so in short, we use a 2-pin header to get the power. We use these resistors and capacitors to adjust the frequency of this 555 timer. Okay, so this is the clock source that would generate a square wave, which then be incrementing the registers in this chip over here. And this is basically a counter. The counter can count from 0 to 10. When it counts 0, DS1 will light up. When it counts 1, DS2 will light up. When it counts 3, DS3 will light up, and so on. After it counts 10, it rolls back to 0. So that's what makes this a LED sequencer. And of course, we always have to have some resistors in series with the LED so we don't burn the LEDs with high current. Okay, so do we have any question related to the schematic? It's pretty clear. Okay, great. So moving on, I want to, just based on these projects I've created, I want to show you what you can do on Altium 365, basically, after you have finished placing, or after you've finished designing a project, right? So you can first look at the schematics. You could also look at the PCB design by just pressing on this tab over here top. And this is the physical realizations of the PCB. And, it specifies where we want to place the LEDs. So these are the LEDs that will be lighting up in sequence. And then these are the resistors that's in series with the LED. And this is the potentiometer. So this is the knob that you can use to adjust the resistance. You can think of it as a voltage divider, actually. It changes the resistance Well, you can use it as a voltage divider. You can also use it as a variable resistor. And in this case, we're using it as a variable resistor. Okay. And these are the two capacitors that we place next to the power source. And this is the counter, right? This is the thing that counts from 0 to 10. And we'll be connecting this component with the other resistors, which then connects to the LEDs. Okay, and these are the two resistors that helps with adjusting the frequency of this counter. And this is the clock source, right? So the clock source is what generates the square wave pulse that's used to increment the counter's register. And this is where we'll be getting the power source. This is the VCC and the ground over here. Okay. All right. And even in the PCB view, we're able to look at things at different layers. So for example, the top layer, what this means is okay. So the top layer refers to this top copper layer. And the bottom layer refers to this bottom copper layer over here. So they're just the two different layers, that's one on top of the dielectric and the other one is at the bottom of the dielectric. Okay, so this is the top layer. And if I click on this, the blue lines, they are the bottom layers. And you can see that I could intersect the blue lines and the red lines because they belong to different copper layers, but I cannot intersect red lines with red lines because that would just mean a short, right? So having a bottom layer, having a bottom copper that allows us to have more flexibilities when we're making the connections between the component. Because we cannot intersect any two wires with different nets. Remember, nets, it's just names we assign to a signal, right? So imagine you're intersecting the 5-volt net with the ground net. That would just burn the board, right? Because you're shorting VCC with ground. Okay, so these are the layers that we can look at for our PCB. And we also have this layer called the top overlay. So the top overlay is everything that's in yellow here. So those are the dexinators. Those are the footprints that's shown on this PCB. So we call the components in PCB as footprint, and we call the components in schematic as symbol. So this is the symbol for the 2-pin header, and this is the footprint for the 2-pin header, right? They're different names referring to the same object, but in different contexts. So this is footprint, and this is symbol. Okay. All right, so the top overlay, this is sort of, you can think of it as acrylic paint. You can paint on top of the resin. So if I go back to the slides again, you can see we have some of these white acrylic paint text that is on top of the resin layer, right? So for us to leave a message or even just label the dexinators for the component. And we can specify where we want to apply those ink using the top overlay layer, which corresponds to the yellow text we can see on the board. Okay, of course, for the bottom overlay, they just becomes the text you want to print from the bottom side. Okay, so we will only be modifying the top layer, the bottom layer, and the top overlay and the bottom overlay for this project. We'll actually we use the mechanical layers a little bit, but it's not too much of a concern. Okay, and if you're interested in learning about the other layers, I can talk about it at the break time. But for now, let's move on to other things we can do on Altium 365. Okay, so other than viewing the PCBs in 2D mode, we can also view it in 3D mode. So this is closer to what we will see after we have ordered the PCB. And remember that I've mentioned some components comes with a 3D body, some of them does not. It all depends on the components we pick when we are choosing the schematic, when we're drawing the schematic. So in this case, I do not have a 3D body for my LEDs, therefore it's directly showing the holes that we'll be using to hold the legs of the LED. Versus for the other ones, I do have a 3D body for this resistor. So these are the service mount resistors. They do not require any holes. Remember that in this picture, this is a through-hole through-hole LED such that we have the holes, but this is a surface mount resistor, so we do not need a hole to solder the component. And you can see they're much smaller. Okay, and this is the chip. And you can look at the footprint's description over here as well. So this is a SOIC. So remember, SOIC is just a name for the package. It tells us something about the form factors of the component. Okay, and if I go to this resistor, it gives me the value 1K. It also gives me the, right here, the size of this component, 0805. So this is the package for that resistor, and it's 80 mils by 50 mils. Okay, so just linking some of the terminologies we saw in the slides. Okay, and we can also flip this board. If I do Control F, that takes me to the back side of the board. And I put down a text over here that says LED sequencer version .1. So these are the texts I have to place in the bottom overlay layer because that's the acrylic paint on the back side of the board. Versus the text that I placed on the top side of the board. Those are the items I have to place in the top overlay layer. Okay, so these are just components or layers from the PCB. Okay. Another thing we can do is to look at the draftsman's file. So this is the file that I've mentioned for assembly view. Okay, so for example, you might want to show the details of a specific section of the board, and then you want to leave some message for someone who's in charge of soldering that part. You want to tell them, hey, be careful about placing this in certain orientations and so on. And you can also put down the bill of materials for that board as well. Right, so bill of materials is another fabrication or assembly files that shows the information of all the components you'll be using for this board. Right, so over here, it shows the dexinator. So dexinator is the unique name that we give to the component. J1, J2, C1, C2. And so you can also have the common sections in the bill of materials that sort of give us idea about what they are. So this is likely a capacitor, this is a resistor, and so on. Okay, it also tells you the quantity. Okay, so how many do we need to purchase per board? Okay. So later we will also generate something called an NC drill file. So NC drill files is in charge of telling the manufacturer where we want to drill the hole and exactly how big do we want to drill the hole. So those information that are given by this drawing views and also this table over here. So we need to drill 21 of these holes and the hole size is 0.51. The symbols is just a way to annotate the board. It does not mean we will actually be drilling the holes in this shape. There will still be circular hole. Okay, but these are just indicators for this lookup table. Okay, so draftsman's files. And next, we also have access to the BOM of this project, right? So the BOM is the same thing as this bill of materials over here. It's short for BOM. Okay, and we can look at the specifics for these components in the BOM. And it also gives an estimate of the cost. Okay, so this is a good way for us to budget the cost of the components as well. Okay, I will have you to explore everything else over here because we would not be using them through this training. But I believe everyone should have some sample projects since you're using the same workspace. You should have some projects that look similar to these. And you can basically click on them and then, review the features I just mentioned. And I will give you around 5 minutes to do that, to get familiar with Altium 365. Okay, I got a question. 175 for a cap. How did it get so high? It might be one that's out of stock. So it's not a common part anymore, maybe. Let me check. Yeah, it's end of life. So it probably means if they need to order this part, we have to restart the whole assembly line of producing this part. EOL stands for end of life. Yeah. It might be a good idea to start picking other parts as well. From different manufacturer. I don't think this is the only 1 microfarad we can find. Or manufacturing part search. Yeah, but for the purpose of this training, is that we don't really care about the cost of the parts. Okay, I'm gonna post another poll. Oh no, this is not a poll. My bad. Yeah. Okay. Yeah, I'm gonna take us all the way to 1 p.m. So I think that's in 40 minutes. And then we have a long break there. How long's the break again? I want to place it at 15 minutes. But if we want to make it an hour, I can do that. Yeah, I don't think we would not have enough time, so yeah, I can make that an hour. At 1 p.m., which I think is in 37 minutes your time, right? Because to me, it's 11. Okay, cool. Yeah, I did the calculation right. Yeah.
I have a question. So I'm looking
Yes.
at this one PCB. Maybe I should share my screen to make this make more
Mhm.
sense.
Yeah, sure.
So on this like FMU board, this little thing looks like it has 3 layers, but
I
let me
I don't think I'm looking at your screen.
this one. Can you see it?
I don't think so. Wait, hang on. I might be messing up my screen. Yes, I can see it now.
It looks like it has 3 layers,
Mhm.
but that's weird to me because most PCB manufacturers I've seen only produce in like even layers, like 2 layer, 4 layer, like 6 layer, I think, or 8 layer. Is this not a 3 layer board, or why is it 3 layer?
I agree that they usually produce even layers, so let's take a look. I think this is a 4-layer board because if you go to the copper layers, you have top, ground, L3, and bottom. Oh, yours has much more. Maybe we're opening up different projects. Let me go to yours. This guy, right? Okay.
I guess this one has 6 layers. Oh,
Yeah, this one would be 6.
so okay, but those look so thin. I thought they were like little set. Okay, so
Yeah.
I guess it leads to a second question: why are
Mhm.
they evenly spaced? Why is it like big space over here and then small space in the middle? Oh,
Yeah, it's really up to the designer. So they might have decided they want to have that specific structures. And I guess another really good reason is so first of all, I mean the thicker the dielectric layer is, the less electrical interference is gonna have on each uh, copper layer. So there may be a reason that they want the signals to be just not getting interfered by the middle two layers, the L3 and L4, which I'm not exactly sure what L3 and L4s are for, right? But this is a design specific issue. Yeah.
Okay, thank you.
Yeah, no problem. If you want to minimize the noise, maybe enlarging the dielectrics layers may be a good solution for that. And yes, checking Discord. It looks like most people still need a bit more time. Let's give another 3 minutes. The cap of my timer keeps turning off. This is kind of annoying. It's not working. Yeah, definitely. I think Altium Designer has the database from Mouser and DigiKey. Yeah, I'm not maybe some other manufacturer too. I guess another really cool thing is if you highlight one component in PCB, it will also highlight that components in schematic. And even the nets too. And the right-hand side, it shows the specific of the components you've selected. Right, so for example, I've selected this connector, then it shows the information of the connector, it shows the port choice, allows me to take me to the website where I can actually order the part. Right, and you could also look at those components in schematics too. And if you go to 3D, it will also focus on that part. Super handy to have. Okay, how does the BOM know what manufacturer to take from? Do we specify when making the BOM? Yes, so you can. So there are two ways to go about it. The first way is you just pick the components when drawing the schematics, and you do not care anything about the manufacturer. You just pick the one with the right schematics and right symbol. Right symbol and right footprint, and then you create your BOM on your own. Or you could be really careful about picking the parts when drawing the schematics, and later you can just use a tool in Altium Designer to generate the BOM. And the BOM should inherit all of the characteristics of the parts that you have chosen when drawing the schematic. Yeah, so the answer is you can make it later, or you can start preparing for it when drawing the schematic. All right, so that is 3 minutes. I'm going to move on to the next step, which is creating a new project. So I do want you to follow me for the specific step. Okay, because I want everyone to create their projects in the right folder. And now is the time for us to go back to Altium Designer. Okay, so please follow me for the step. And let me bring up my guide over here. So now we're still creating a new project. Okay, so after we get to here, we make sure we have connected to the workspace. That's all good. And then we go to File, go to New, and then select Project. So File, New, Project, and that should prompt us using this window over here. So different couple ways for us to create a project. You can create the projects on Altium 365 Workspace directly, and then introduce version control. That way you can, for example, work on the projects on one computer and then upload it to the workspace. And then you might go home and then want to work on it at home. Then you can just pull it from Altium 365 and then work on it at home. Versus if you want to create a local project, this will create directly on the computer you're working on currently. And in order for you to use this project on a different computer, you have to have a hard drive or whatever ways to package the zip folders and then share it with the other computer. Okay, but for the purpose of this training, we want to look at how we can take advantage of Altium 365. So we'll be creating a project from the workspace. And by default, the workspace should come with some template, but I do want you to start from scratch. So let's start from empty. So we do not want any preset templates for this project because I want to show you what is the bare minimum, what is the most basic things that will make up a project. And after the workshop, if you want to explore the other templates, just feel free to select different selections over here. It would just give you some templates, preset templates for the schematic files and the PCB files. Okay, but for this training, we will use empty under PCB. Okay, let's give this project a name. I'm going to call it LED Sequencer Peggy. And you probably want to have a unique name here as well because everyone's uploading these folders to the same workspace. So this is my first LED sequencer project. And let's enable version control. Later, I will show you what happens after you have enabled version control and you have been making consistent commit to the copy on Altium 365. Okay, so when we create a project, do we have to make it in the folder we want it in, or do we put it there later? So you do want to put it in the folder that you just created in the Altium folder. So what you do is to click on this advanced button over here. So the first file path is on Altium 365, and the second file path is on your local computer. Okay, so creating this project not only creates a copy on Altium 365, it also creates a copies on your local computer. So it's very similar concepts as Git. You make modification locally on your computer, and then you push that local copy back to the cloud and have it to synchronize. Okay, so what you probably want to do is after you have this folder path, you want to click on these three dots and then navigate to the folder that you have just created using your name. So in my case, it's under Sample Projects Altium Workshop Peggy. But for you, it's the Altium folders that Anna created. And then in that folder, you should have a folder with your name. So you should select that folders with your name. And then click on OK to update the file path that you want to store those files in on Altium 365. Okay, so another 30 seconds for student to change the path. You can explore the parameters here. I usually don't do anything here because you can just modify the parameters of this project after you get started with designing. But yeah, the most important thing is to enable version control and then also to specify the path. Okay, I got a question. Yes, so pressing on empty and then give a name version control. Yes, so if you can click on these three dots under the folders tab, and then that should have this window popped up that says choose folder. And then you can expand the projects folder and then expand the Altium folders that Anna created. And then you should find your folders in that Altium folder. And after you've selected that folder, just press OK. It should update the path over here. Yeah. And if you need more help, feel free to share your screens as well. Oh, I'm sorry. Did I just stop sharing? My bad. Okay, hopefully everyone can see my screen now. Okay, cool. Awesome. So everyone's good right now? Ready to move on? Okay, so there's another selection here called Constraint Manager. We will not go over how to use Constraint Manager here. This is actually related to the design rules step in PCB workflow. So this step over here. It's advanced tools that Altium have released around a year ago to manage the design rules a little bit more conveniently. But for the purpose of this training, we're not going to go into these advanced features. We'll still use the most basic way of setting the rules. So if you're interested on your own projects, you can, not for this workshop though, for other personal projects, you can enable the Constraint Manager. But something I want to warn you about is you can only use the Constraint Manager with professional license and enterprise license. You cannot use Constraint Manager using the standard license. So I believe everyone here has a professional license. And there's no way to roll back from Constraint Manager back to the regular editors. There is a way to roll from the regular editor, which is the one we're going to use for this workshop, to Constraint Manager, but there's no way to go the other way around, right? So when you're creating a project, make this decision based on the type of license your teammates have. And yeah, basically based on the type of license your teammates have. Because there's no way to go back to a state without a Constraint Manager. Okay, and this is just something we use to manage the rules and constraints. So those are the size of the vias, or the width of the tracks, or the clearance, the spacing between the components, and so on. Okay, so we created a project. We specified the folder path on Altium 365. I started at a specific path on my local computer. I'm happy with all the settings here, and then I can click on Create. So this usually takes a little bit because you have to set up all of the version control systems. Okay, and after we've created a project, you should see that in this projects panel, I should see a project that says LED sequencer Peggy, and for you, it's just going to be your name. If you don't have those rules set, how are you to do DRC? So Altium Designer comes with default DRCs. So they already have some rules about the clearance, the constraints, the size of the vias and such. The constraint managers and the constraint editor, those are just tools for you to edit those default settings. Yeah, so DRC will still be checking based on the default. Awesome, cool. All right. And now let's create some schematic files and PCB files for this project, right? So to create those files, we come to this projects panel. So we call these things panels. They're just things that dock to the side of the application that allows us to access the features in Altium Designer. We can right click on that project and then select Add New to Project. And let's create one for schematic. And let's create another one for PCB. And we can basically close the schematic list windows that opened. Okay, so I'll create schematics and create PCB. So right click on the project, go to Add New to Project, and then go to PCB. Okay, so repeat the same process for the schematics. Now you should see there are 2 files populated under this project. And I would like you to just experience changing the name of the projects. I'm sorry, not the project, the files, by right-clicking on the files and then select Rename. So I will call this the LED sequencer schematic. Hit Save. And also change the PCB into LED sequencer PCB and hit save. Okay, let's give a couple minutes here. And also start releasing a poll. SCH stands for schematic. Another 40 seconds. Okay. All right, so assuming everyone already have this project created, the next things we're going to do is to save this project back to Altium 365. Okay, so now when I go back to my workspace, right, and navigate to my folders, and I do not see the schematics and the PCB. That is because I've only created the projects on Altium 365, but I have not synchronized all of my changes from Altium Designer back to Altium 365. So let's see how we can upload the schematics and the PCB files to Altium 365 such that I can view them over here through the web browser. Okay, so to basically commit to the server, we can go back to this projects panel. If you see this asterisk signs right next to the projects, that probably means this project is not really fully stored on local computer, right? So we can use Control S to save the projects locally. Oh, sorry, maybe the asterisk means not saved to the server. Okay, never mind. So in order for us to push the schematic files and a PCB file we just created, we can click on the Save to Server button over here, which would have this window popped up. And I can add a comment, something like add schematic and PCB to the project, and then press OK. So this is the process of Git pushing all the changes back to the cloud. And now if I come back to my workspace and then I sort of refresh this project, It might be a good idea for me to reopen the project. Okay. Now we can see that there's a schematic created and there's also a PCB created on Altium 365. So this is how we can synchronize the changes from local copies back to Altium 365. All right, let's use a couple minutes to save our projects, schematics, and PCB files to the server by pressing the Save to Server buttons over here in the Projects panel. And we have a couple minutes for that. Oh no. What more seconds? Okay, if you don't have those rules set, oh, sorry, the next question. How does Altium handle source control conflicts? I think it will prompt you it will have a window pops up. So for example, if you have two people modifying the same schematic, it will be asking you which version do you want to get. Do you want to take the changes made by this user or do you want to take the changes made by the other user? So it's very similar to resolving conflicts on GitHub. Yeah.
Does it do any sort of like merging, or is it only like choose one and move on?
It do mergings across the sheets, but not on the same sheet. So for example, someone might be making modifications in the PCB and the other person making schematics, then they can merge those changes. But if two students are making changes on the same schematics, then that's where the conflicts arise. Yeah, does it make sense? Like if they're working on different files, it's okay. But if they're working on the same file, that's where the concerns arise. Awesome, cool. Yeah. I don't remember specifically what the windows were prompted, but I do remember pretty clearly that if you have different people working on different files, that should be okay. Okay, cool. So hopefully everyone have already saved the projects to the server. Now for the next sections, you can just sit back and listen. I'm going to give a short introductions about this entire interface and schematic document. And then we're going to start taking the break. Okay, and after we get back, I will give another review of the schematic working environment. Okay, but idea is for this portion, you can just sit back and listen. All right, so now I'm going to come back to this Altium Designer application and then open up my schematic document. Right, and you can also tell the type of the type of files by reading the file extensions and the icons for the file. I double click on the schematic files in the projects panel to open up the project and the schematic files. And this is basically the working environment in Altium Designer. So the first thing I want to mention is the panels button at the bottom right corner. This panels button, you will find yourself clicking on it a lot because that's where we can access most of the features in Altium Designer. Right, so for example, opening up a project could be a feature. Therefore, we have to do it through the projects panel, and we can open up the projects panel by clicking on the panels button. Another thing we can look at is the properties of this current schematic document, and we can look at it by pressing on panels and then press on properties. So that should open up this properties panel over here as well. Okay, there we go. Okay, so for this specific document, you can change the units, millimeters or mils. You can also change the grid. We'll look at how to use them a little bit later. And you can also change the template of this specific file. So for example, if I want to make this schematic sheets a little bit bigger, I can use this drop-down menus and select the other sizes. I'm going to keep it at B because we do need a little bit more canvas size for our project, and so on. So, right, the panels button is where we can access the other panels for different features. And once we have those panels open up, they could be opened up in 3 different modes. So we have the dock mode, the floating mode, and the pop-up mode. So first we'll look at the dock mode, which is similar to this projects panel over here. Docked mode just means these panels could be docked at any edge of this application. So right now this guy is docked to the left-hand side. I can have it to dock to the top side, or the bottom side, or on the right-hand side, and so on. So this is the dock mode. Okay, and after dock modes, we have the second mode, which is called pop-up. So this is extremely helpful, especially when you have limited screen space. You might want to constantly access the feature from the panels, but you don't want the panels to take up too much of your screen space. Then you can put it in pop-up mode, meaning that it will be hiding the panels on an edge of the application. If you want to access that panel, you just need to move your cursor close to that name, and then it's going to pop up the panels, and then you can access those features there. Okay, so for example, this is for projects. And if I want to look at the properties panel, I just need to move my cursor to properties, and then now it's popping up the properties panel. If I move my cursor away from the panel, then it's going to merge itself back to the side of the project. Okay, so this is something that could help us to save the screen space. If you want to go from dock mode to pop-up or pop-up to dock, you can go to the panels, and then there is a little pin icon over here. If you press it, it looks like the pin is pinning down. That means it's in dock mode. Versus if you unpin it, you click on the pin again, and the pin looks like it's sideways, then it's in pop-up mode. And then after I move my cursor away, the panels are going to hide itself back to the edge of the application. Okay, so those are the 2 different modes for panels display. The last mode is called floating mode. That means, for example, you might have 2 different screens. You have one screen for you to look at the schematics. You may want to just use a different screen to look at the components you want to choose for your project. Then you can basically, for example, I will use another panel for this. So let's say I want to start picking up my parts, my components, and I want to use the manufacturer part search. And I open up this panel. I can enter the floating mode by basically dragging it off, and then I can put it on a different screen. That way, when I'm starting to pick those components, I have more space to look at all the specific for these parts, rather than having it to kind of taking up my space to look at the schematic. Okay, so 3 ways. We have the dock mode, pop-up mode, and floating modes to access the features and the panels. And we open up the panels by pressing this panels button over here at the bottom right. Okay, the next thing I want to talk about is the context-sensitive features in Altium Designer. So what it means is I have different type of documents in my project. I have schematic documents and I also have PCB document. After I open them up, it's going to populate in this document bar over here on top, and you can basically navigate to a different document by pressing these tabs. Context-sensitive means if I have selected a schematic document, I can only access the menus and the features for schematic. And if I've selected a PCB document, I can only access and use the features that are specific to the PCB. Okay, so let me try to conveying this point a little bit more by first splitting these two documents into two sides. Okay, so I'm going to place this schematic document on the left and PCB documents on the right. I can do that by right-clicking on any one of these files and then select split vertical. Okay, so now I have, sorry, I probably said it opposite way. I have the schematic on the right-hand side and the PCB on the left-hand side right now. So while I'm doing my PCB design, I can also look at my schematics to reference. Okay, coming back to the context-sensitive idea, if you look at these tools over here, so we call this the active toolbars. This is where we can drop down the components, we can drop down the wires, drop down the different components, and so on. They look different in the PCB document and in the schematic document. Okay, so that's one way of showing the context-sensitive features in Altium Designer. Another way is, let's say that I am first focusing on the schematic document, and then I press this panels button, and this is the set of panels I have available through the schematic document. Versus right now, if I click on this PCB document, it's now focusing on this PCB, and I click on the panel buttons again. You can see that I have a different set of panels over here. Right, so if you're looking for specific panels and you cannot find it, just make sure you're focusing on the right document because of the context-sensitive characteristics. Different focused documents will give you different panels menu. And the same thing applies to this menus over here as well. So if I have PCB focused, it has the routes menu and the tools designs menus, and actually each one of them will look different once I have the schematic document focused, because now routing just turned into simulate. Okay, so that's just another thing to look out for. Okay, so now I'm going to sort of merge all of my documents together again to just look at the schematic document. Okay, for us to navigate within the schematic document, I can hold my control key and then scroll the mouse view to zoom in and zoom out. Or I can hold the right mouse button and then to drag the canvas by moving my mouse. Moving my mouse. Okay, so those are the two basic navigation skills in schematic document. So we hold control and then scroll the mouse view to zoom in and zoom out. And we can hold the right mouse button to drag the canvas. Okay. And the last thing I want to mention is the active toolbar. So the active toolbar refers to this little bar over here. It helps us to, usually comes with a divider over here. The things that comes before the divider, they are for modifying the schematic sheet, versus the things that's after the divider, that's for placing different components available on the sheet. Right, so for example, before the divider, we have a feature to turn on and off certain filters. So this controls what components you can select. And the second one is for dragging the object around, or you could be selecting the objects in an irregular shape. If you see a little white triangle at the bottom right of these icons, that means if you right-click on that icon, it will allow you to access more features. Okay. Versus the icons that's after the divider, this is where we can be placing the component, placing the wires, placing the symbols for VCC and ground, the vias and the ports, and so on. Okay, sorry, VS not for schematic, VS for PCB. But this is basically what the active toolbars can do. And a lot of features you can access through the active toolbar, you can also access through the place menu and the view menu. So it all depends on how you would like to modify your schematics. Okay, so that is 1 p.m. and I'm going to start a timer for 60 minutes. So you can have 5 minutes to kind of explore this environment and then use the rest 55 minutes to eat something, get lunch. Yes, thank you, Anna. And if you guys have any question, I will be here 10 minutes before the start of the session. So we go from 1 p.m. to 2 p.m. and I will be here at, let's do 15 minutes. I will be here at 1:45 in case you have any questions. Right. Any question before we go into the break? We're all good? Cool. Okay. Awesome. See you guys in a bit. It's raining really hard here in Sacramento.
Well, actually been really nice the last couple days. We had like a couple of like cold fronts. But today is really sunny and it's like what, 70s? Like perfect weather. It's probably
Wait,
not
that's
gonna
not.
last long.
Yeah.
Where are
I wish
you?
we have that weather here. I'm in Sacramento, California.
Oh, right, you just said. What am I
Yeah,
thinking?
no problem. Yeah, I'm about 30, 40 minutes away from Davis. So, yeah,
Hmm.
about 6, 8 hours from LA, 2, 3
Oh,
hours from San Francisco.
cool.
Yeah, nobody knows Sacramento is like the capital of California. Everyone knows about LA and San Francisco, but not Sacramento.
Yeah. I remember they had us learn it in fourth grade. All the
Really?
capitals. Yeah.
Okay.
I don't know how many people went to elementary school in Texas, but they have us like memorize all of the states and their capitals, and it's so hard.
Okay. Well, I'm happy that at least run into one person who knows Sacramento is the capital. Yeah. No, it's raining really, really hard. Wind's blowing. Yeah. A lot of people said we're able to see northern lights last night, but I didn't see it. It's all cloudy.
I'm here too. Some of my
Yeah,
friends went to go see them.
it was sad. All right, it is. I almost said 12 p.m., but no, it's 2 p.m. and we're ready to get started. Okay, so just a quick overview or reviews of what we talked about before we left. We look at the basic design environments and schematics. We look at we have a document bar that can allow us to navigate to a different document. We have this active toolbars that would give us tools to modify the schematics and also the tools to place the components onto the schematic. Okay, we also look at 3 different modes of the panels. One of them is stock mode, which is this projects panel over here, and the pop-up modes, which are the panels over here on the right-hand side that will hide the panels will hide to the right-hand side if I do not have my cursor on top of these buttons or on top of and on top of those panels. The last one would just be the floating mode, and you can basically get into floating modes by just dragging and dropping these panels. Okay. The panels button is where we're able to access all the panels that we saw on the edge and also in the document. And in fact, since we have so many features in Altium Designer, it becomes really, really hard to memorize everything. Sometimes we have to reference to the documentation. And normally the way we go about it is to look at the name of the feature and then we type on Google and try to get the documentations on that feature. But in fact, there is a really, really useful shortcut keys available, which is function 1. So that's the F1 key, I think right above number 2. And if you, for example, have a specific feature selected, let's say I am interested in knowing what the selection filter would do, I will first click on the selection filter or just hover my cursor over to this icon and then press F1. This is going to automatically open up a web page that comes with the documentation for that specific feature. Okay, so you can do that to almost everything in Altium Designer. So let's say you're interested in knowing about what this projects panel would do. We'll first focus on this projects panel by basically left-clicking on the panel. Press F1, and that would just open up the documentations for the projects panel. Okay, super, super helpful feature. And other than the active toolbar and the panels, you can also use F1 on any of these items in the menus, right? So for example, I don't know what this place bus means, then I can just click on place and then hover over to the selection that I'm confused about and then press F1. And and that would just pop up the documentations related to that selections in the menu. Okay, so during the exercise, the hands-on portion, if you have any questions related to a feature, you can press F1 to open up the documentation, or you can directly ask me. And for students who finish the parts early, you can also use this feature, the F1 key, to explore the different functions available in Altium Designer. Okay, that is awesome. And now let's come back to this map. We have just finished creating a new project and pushing it back to Altium 365. We have also looked at all of the environment setup in Altium schematic document. And next we will work on placing the part onto the schematic canvas. Okay, I'm going to share a screenshot of the schematics with you and also all the components we'll be placing. But for this portion of the presentation, I would like you to just sit back and listen to how I place the components on top, and then I will give you about 10 to 15 minutes to complete the schematics for your own project. Okay, so just sit back and listen for this portion. All right, so for component placement, of course, the first thing what you do is to find the components in Altium Designer and then place it on the schematics. So there are two panels that are commonly used for placing component. The first one is this components panel, and the other one is the manufacturer part search panel. So let's first explore the components panels real quick. Okay. So the components panels actually allows you to drop down the parts that comes from the Altium 365 workspace. That's why we have these blue cloud icons next to a lot of things, even in the panels too. So anything that comes with this blue cloud icon, they're only accessible when you're connected with a workspace. So your workspace may look different from my workspace. So the parts you have available may be different from the parts I have available over here. Okay, and if you're interested in learning about those parts available on Altium 365, I'm going to go to here real quick. You can look at all those components by going to this libraries folder and then coming down to this components folder. This is where you can get a view on all of the components available on Altium 365. And you have the freedom to add more parts or remove the parts from here. That's no problem. Okay. And okay, let's just go with something simple. Let's say I want to place a capacitor. And these are all the capacitors available online through Altium 365. Okay. I will be able to look at the specifics by basically clicking on expanding the details menus at the bottom. And over here, let's try reading some of these parameters together. Okay, so for this specific capacitor I just chose, it comes with a package of 0603. Of course, it's a capacitor. And its value is 1 microfarad, and it's a ceramic capacitor. Right? And then you can basically tell the type of this capacitors by looking at its model. This is another window you can explore or expand. And over here, it shows the symbol. So symbol is how the component looks like in schematic. It also shows the footprint. The footprint is what the component looks like in PCB. And so you can obviously tell that this is basically a surface mount capacitor. Right? Other than that, we also have access to some of the references about this component. Right, so if I click on that, that should take me to a data sheet related to the specific capacitor. We always have access to that, and we can also look at the manufacturers that are still currently producing this component. And on the top right corner here, this shows the stock and the price for this component. And you can also look at the data sheets based on the manufacturer. Right, so those are the informations we can retrieve for each component. And if I want to start placing this component, I can directly drag and drop this component. So dragging it out from the components panel and just left click to place it down. sorry, not even left click, just release the left button to place the component down. Okay, if you want to place multiple components at the same time or in a sequence, then you can right click on that component you want to place and then select place. So it's usually the first option. And that way you basically have the component snap to your cursor, and then every time you left click, it's going to allow you to place the next one. And so on. Okay, so that's how we can place the component from Altium 365 through the components panel. And other than this, you may also be finding some other components library online you want to import into your library. Other libraries online you want to import into your Altium Designer. And this is also where you can access those other libraries as well as through the components panel. Okay, so there may be situations where you're not able to find a particular components you want. It's a very niche component, and you just cannot find it online, or you cannot find it through Altium 365. Then this actually comes into play for the other panels, which is the manufacturer part search. So for the parts that are available through the manufacturer part search, they are directly linked to the component vendor database. Okay, so through the manufacturer part search, you will be able to find much more components that are not available through the components panel. But I guess one downside about this is not all of the components comes with a valid symbol or a valid footprint, right? So every time when you're placing the component, you want to pay attention to the models of the component, right? So now I'm going to try putting down a couple of components that I found, that we have in the LED sequencer. The first thing is a 2-pin header. And I will share the parts number with you. But basically for this guy, it's going to be M20-999-0245. Oh, sorry. That is because I do not have this set to all. So if I search for a part that does not belong to a passive component, then it's not going to show up the entry. I have to make sure this drop-down menu is set to all. Therefore, I'm doing a global search to all of the different parts. Okay, let's try typing in that parts number again. 0245. Great, this is the component. Oh, yes. Do I have a question? Oh, okay, I think that was just accident. Okay, so for this 2-pin header, over here, I can check that it comes with a symbol and a schematic. It also comes with a footprint and PCB. So this component is good to use. And I can also read its data sheets to, try to decide whether or not this is the connector I'm looking for or not. Is this the right spacing? Is it using the right component? What is the materials for the pins, and so on. Okay, and if this part looks like the one I want, I can use the same technique. I can either drag or drop, or I can right-click on the component and then select place. So while I have this component stacked to my cursor, there is a way for me to directly modify the property of this component before placing it down. And I will be accessing the properties by pressing the Tab key. Okay, after I tap the Tab key, the properties panel is going to show up, and then it will allow me to change the designator. So let's say I want to make this component designator to be J1. And I can also add a comment, something like 2-pin header for power. Okay, and the descriptions and all of the other parameters that are inherent from the parameters that we just saw and the manufacturer part search parameters. Okay, and everything looks good right now. I can come back and then press this button to continue placing this component. Just like that. If I want to rotate the component, I can press the spacebar to rotate it. And you can also see, after I have placed one component with a set designator, my next component on my cursor would automatically increment the number for the designator. So this one becomes J2, and the next one becomes J3, and so on. Versus if I just place the components without specifying the parameter. So let me come back to here. So now the designator says J question mark. It would not increment the question mark or change the question marks into numbers. It would just directly be placing the components down with that question mark as designator. And we will have a step later, which is at the annotation step right here, that will show us how to automatically assign those designators to all the components. So normally you do not need to worry about naming these components while you're placing it. You just want to place it at the right place so it's easier for you to make the connections. Okay, and coming back to the context-sensitive feature in Altium Designer, right? So we saw the menus and the panels that would change based on the documents that we're focusing on. This is the same thing for the properties panels as well. So what it means is if I have properties menus open, and then I select, okay. I have the properties panels open. If I select just the document, that means pressing at any empty space on the document. It is showing the properties of the document. Versus if I select the component, then my properties panels would be showing the specific about the component. Okay, so the properties panel is also context sensitive. It would change based on the items we're currently selecting. Okay, and another useful tool for us to use is the grid. So let's say that I want to place the resistors and the LEDs. Okay. Come back to the manufacturer part search. Make sure my drop-down menu says all, and then search for the part number. Okay. Like sometimes it becomes really hard for me to align. Let's say I want to eventually connect all these capacitors together, but it's really hard for me to align them in a straight line. So one thing we could do is to change the grid of this schematic document. And we can change it by going back to the properties for the schematic sheet and then change my snap grids maybe to something like 400. Right, that just means now I could only place those capacitors at 400 grid. So that makes it much easier for me to align all the components versus when I have a super small grid. Let's say something like 10 mil. I have a lot more freedom to move these parts. Oh, that was strange. Oh, sorry. The snap should be 10. Okay, that means I'll have a lot more freedoms to move these components and place them, but it becomes much harder for me to place these components directly on top of each other. Right, so when you're placing the components, it's usually a good idea to change the snap grids into something big, for example, 400 mil. This way, it's much easier to align the components together. Okay. Do we have any questions for part placement, or we're ready to move on? Okay, cool. Yes.
When I get the 2-pin header on there, it says J question mark. How did you get it to say J1? You just typed it in.
Yeah, so you can, if you have placed the components already, you can press the component again, and then go to the properties panel to change the designator. Or there is another way to change it while we're placing, is by pressing the tab key. So for example, if I want to place this capacitor, and I can put it down and then go to properties and then change the name. That's like a lot of steps. Versus right now when I have this components on my cursor, I can press the tab key. So that is the key above the cap lock, or the key that's next to the letter Q. And that would just that would pause the execution in schematic and take me to the properties panels, and I can directly change it in the Dexinator space over here. So later I will show you a trick where you do not have to do this for every single component. You can basically have a tool to automatically assign unique Dexinators for all the components. Okay. All right, if everything looks good, I'm going to start posting the component parts number required for the project and also a screenshot of the schematic. And usually at this step, some PCB designer might have one of these reference rulers that sort of shows the size of the components and the packages to give a sense of how big of a components we need to place on the board. And I've placed a couple links in the announcements channels for you to explore. So if you're interested in looking at what a reference ruler looks like, you can check the link on Discord. And with that components posted, let me also give a screenshot of the schematic. Theoretically, you should be able to find all of the components through manufacturer part search, because I got the part number directly from there. Okay. There we go. I will give around, let's say 15 minutes for this part. And I'll be here if you have any question. I will also start a poll on Discord. You do not have to make any connections. It's just for placing the parts. Oh, I guess another thing I forgot to mention is if you want to place the symbols for VCC and ground, you can access them through the third icon after the divider in the active toolbar. So if you right-click on this icon over here, you can choose to either place the ground or place the VCC power port. And something I like to do at this step is to have the properties panels on the left and the manufacturing part search panels on the right. So that's just going to help me to look at both panels at the same time. I don't have to, search a part and then change the properties and then have to click the manufacturer part search panel again. And remember that spacebar is for rotation. And the tab key is for pausing and modifying the properties.
Wait, Peggy, is there like a list of all the components we're supposed to put on there somewhere, or do we just
Yes. I posted it on this core announcement channel.
Oh, I see. Okay,
Right
thank
here.
you.
Yeah, no problem.
Sorry.
Yeah, it would be so confusing if you were supposed to follow what I was doing.
Yeah.
Everything's here. If you copy and paste these part number and then put it in the search bar of the manufacturer part search, the first items that pop up should be the components we're using
Okay.
for the
Thank you.
project. Yeah, no problem. And I messed up the indents here. Just bear with me. Okay, I got a question. How do I get the other object to get a destinator when I copy them in again? Yes, so in order to do that, you can, you have to right click and then use the place feature to place the component. If you just drag and drop, it would not be able to update or increment the destinator automatically. So after you have right clicked and click on placed, you have a component snap to your cursor. And then before you left click to place it down, you want to press the tab key. So that is the key right above the caps lock key or right next to the Q letter key. Okay, and in this menu, it will open up the properties, and then you can change the destinator for this first one. So let's say I want to start from DS4 for some reason. And then I press continue, which is this button in the middle. And now I can start left clicking to add the components. And now the next one will automatically increment the destinator number. Yeah, so the key idea is to place the components by right-clicking. I'm not sure why it's so hard for me to say that word. Right-clicking and then press place. And before you place, press the tab key to modify the destinator. That's how the destinator can increment. And after you finish placing the component, you want to exit out from the command to keep placing. We can just right-click to exit. Or I think the escape key also works. Yes, the escape key also works. Awesome, cool. Yeah, but we will later show a way for Altium Designer to automatically assign those numbers for us. Yeah, so you can put down a destinator at the step, or we can do it in the annotation step. Yes. So we have another 3 minutes left. How do I get the components to show their values? Yes, so you will be doing it through the same way. Let me first grab a resistor real quick. Okay, so now I have this resistor, but it probably does not show 10K, it shows something else. So in order for me to change this value, I can press tab again to go to its properties panel. Not exactly sure why it's showing the document. Okay, let me actually grab a capacitor. Okay, there we go. Okay, so while I still have this component on my cursor and I haven't placed it down, I can press the tab key that would take me to the properties panel. Oh, I should probably, so this is the key. This would take me to properties panels of this component. And then I would just change the values in this common section over here. So before it might save the part number, but now I probably want to put something like 50 picofarad because that's what this capacitor is. The one we're using is 1 microfarad. So you want to still pick the capacitors with the part number I shared, and then change the common section into 1 microfarad. So something like this. And then press enter. And then now the description has changed into the values. Okay, and that's the same for resistors as well. All right, next question. How do we make the schematic sheet a little bit bigger? Yes, so to make it a little bit bigger, we need to focus on the schematic document. Right, so if I go to the properties panel, it should say document option instead of components. And you can focus on the document by pressing any empty space on the schematic. You probably have to scroll down, but there should be a section that says page options. And you can change the sheet size over here. So I think A is the smallest, B, C, D, E. So these are the different sizes. Okay, so I got a question. Yes, no problem. The 555 timer does not look the same. That is a little bit strange. Okay, let me copy and paste the part number I shared and see if it matches. Okay, so this is the part number, and then press enter. And the first one that showed up should have the same model. Let me try looking for yours. Yeah, maybe try retyping the part number. The NE555DR Texas Instrument, and see if you find a similar component. Oh, yeah, no problem. It should be in the manufacturer part search. Okay, so next question. How do you move multiple objects at once? Yes, so to move multiple objects, you first select them. There's a trick here, meaning that if you start selecting, for example, making the selection box from top left to bottom right, wait. Okay, yes, just proving my theory. If you start from top left to bottom right, it's only going to select the part that are fully enclosed by the box. Versus if you start from the bottom right and go to the top left, it's going to select all of the components that are fully enclosed in the box. Okay, so the way I remember it is the left is always partial and the right is always enclosed. And after you have selected those components, you can basically just move them at the same time. But make sure before you move, your cursor should turn to this cross symbol. Okay, hopefully that helps. Okay, next question. I had to issue and had to reconnect. I'm confused. Yeah, so you do not have to connect the components at this step. You only need to place the components down. I will go over how to make the connections a little bit later. Or if you need to delete. Okay, let's take a look. Oh, okay. You can close this window. I think this is the component. I forgot how to even enter that page. But for you to go back to the schematic, you can just close this components panel. Sorry, not components document, because you do not need to make modifications on the models or the parameters. You have a new tab for the parts you don't know how to place. Can you try right-clicking on... Here, I have the image here. So try right-clicking on this tab over here and then close that. And I think that should take you to the schematic page. You have a fatal error. Okay, let's take a look. can you share your screen? Okay, but before that, let's see if there's any other student have any questions. Okay, cool. So this is the only thing. All right. Let's take a look. Oh no, my screen is dark. Okay, cool. We're here. Okay, so it says validation detected a failure. Yeah, try pressing cancel. And I'm wondering what is generating that error. So it says component folder path not specified for. Oh, okay. Yes, if you can close this messages window. And then do you see there's a folder? Yes, exactly. So press on those three dots. It should take you to here. Yes. And then it should be under components. So expand the components panels a little bit. There should be something that says connector. Try to think how I could get to your stage so I know how to solve it. Oh wait, I think it's working now. Cool. Yes, now try saving the components. So go back to the component document and Control S to save. Yes, and then close that one. The first option. Yes, save. Anything, yeah, exactly. Yeah, this will usually take a bit. Okay, cool. And now try placing that component again. Oh, yes, you actually want to go to manufacturer part search. Yes, exactly. And then right click on the component, select place. Yes, awesome. And try placing it down. Yay, it worked. Okay, cool. Say how many people finished. Do you guys need another 8 minutes? That could work. Yeah, no problem. All right, let's do an 8 minutes timer. And yeah, for student who finished, feel free to use F1 function 1 key to explore documentation. Right, even for the little selections over here. So if you're not sure about what the snap grids would do, you can focus on snap grid and then press F1. And that should bring you to the documentation for the properties panels. And then sometimes it takes you directly to that feature. Sometimes you sort of have to do Control F to search for that specific space. So for example, snap grid over here. What is the VCC in the screenshot? Yes, so for the VCC, you can go back to where you place the ground, and then for every icon that comes with this little triangle at the bottom right, that means you can right click on that icon and access more items from the same icon. So for the VCC, that would be the second selection over here. Yeah, and I guess one more thing about it is after you have selected a feature, the icon turns into that feature. If you want the previous one, you have to right click on that again and then select the one you want. That is different from the current items. Just another 3 minutes. What does the X mean here? Yes, we will not be placing that X right now, but essentially what it means is, so we do not want to connect anything to that pin, but the ERC, the electrical root check, will actually generate a warning or an error, I think, that says, hey, this pin is not connected. This is wrong. You cannot convert it into PCB. So the little X is just something for me to place at that pin such that it could suppress the error generated by that pin. Yeah, we will do that at the ERC step, this step. But for now, you can just leave it blank. You don't have to place the red cross over there. Yeah, placing the component is sufficient. Another 30 seconds. Okay, if I need more space, how do I change the sheet size without restarting? Yes, so to change the sheet size, you can first focus on the document, meaning that you just left click on any empty space on this schematic sheet. And then you can go to the properties panel. So you can go to the panels button and then press properties, or try to find the properties panels either at the bottom of this menu bar or probably on the right hand side. There should also be a panel bar over here. So after you found the properties panel, scroll down to this page option section, and there should be a selection here that says sheet size. So I changed mine into B. I think the default is A, But if you want even bigger sizes, you can go to C, D, or E, and so on. So that way you can still keep your design while changing the sheet size. Okay, a couple more minutes help. But did I use it? Yeah, no problem. Okay, looks like a lot of people are getting closer, so let's do another 2 minutes. Okay. So remember, you do not have to put down the numbers or the designator numbers for all of them. We would use the tool later to assign the numbers. But if you want to do it at the step, you can also do it. Ten more seconds. Okay. All right. I will come back to this diagram here. So we just finished part placement. Next thing we're going to do is wiring. So that means connecting all the components we just placed on a schematic sheet. Okay. So before we start, there's one preference I want you to turn on, which is going to make our job much easier. And that selection is under the preferences menu. So for this portion, just the first part, I would like you to follow what I do. So let's come to this preferences menu, which is this gear icon over here in the top right corner. Then that should open up this preferences menu over here. And in this menu, we want to okay, I didn't place. I believe it's under schematic and general. It's not. Okay. Sorry, let me search for this feature real quick. I might have accidentally deleted that entry in my notes. Okay, got it. So under schematic, graphical editing. Yes, and make sure always drag is enabled. The selection over here, just make sure the checkbox next to always drag is on. So if that checkbox is on, that means right now, if I move a component around, after I've made a connection, the wire will move with my component. Versus if always drag is off, so you don't want to disable it, but I'm just going to show you what happens. Now only the components will move and the wires will not move with the component. Okay, so having always drags help us to sort of adjust the location of the component after we have made the connection. Okay, so now you can sit back and listen. I will show you how to make the connections, and then you will be given about 5-10 minutes to make all the connections. All right, so we have to make sure the always drag is on. And that just means if I want to make connections between, for example, all of these resistors with all the LEDs on the right-hand side, I could for sure use this place wire 2 over here. So we can left click and then start making the connections one by one. Or I could select all of my LEDs and then basically move it close to, oops, sorry. I'm going to delete this wire real quick. Okay, select all of the LEDs and move it close to these resistors to make sure that I've already made a connection. And now if I drag all of these LEDs away, the connection should be made automatically. Oh, sorry, it's my grid size. I need to change my snap grid to be 100 or 10. So this way I could actually move my LEDs right next to the resistors. Okay, so now if I move these LEDs to be snapped to these resistors, and I can move these LEDs away. Oh no, what's wrong here? Okay, there we go. Sorry, I probably did not place them close enough. Now I have this wire automatically connected between the resistors and the LEDs, just because I have the always drag features on. Okay. I usually like to keep my snap size to be 100 when I'm drawing the wires. So this is one way of connecting, which just means you move the components close to the other and you drag it away. It's going to automatically make the connection. Another way to make the connection is, of course, just using these place wires tools to directly to sort of manually make the connections. Right. So every time you left click on a pin, you want to make sure you see this red hotspot before you left click. That just means after you have clicked on it, after you have clicked on the pins, it will start a wire with the connections at that specific location or to that specific pin. And while we're placing the wires, we can press the spacebar to change the direction of the angle. Just like that. And I want to connect this port with this pin over here. I can just keep left clicking. And let's say I have already placed a bunch of quarters. I want to sort of go back to the previous quarter. Then we can use the backspace key. So that will just bring me back to the previous corner and helps me to continue making the connections. Okay, so the main takeaway is the space would change the angle and backspace will delete the previous angle. And that's basically how we can make the connections. And so let's try these two again. So I'm going to move this part close to the part on top. Well, I guess it doesn't always work. I'm not sure. Yes, there we go. And there it has made the connections between the resistors and this potentiometer. All right, so that's all I have to say about wire connection. And let's give about 10 minutes to do all the connections. Okay, so I've got a question. How do you zoom in? So you want to hold the control key and then you scroll the middle mouse wheel. Yeah, so hold the control key. And then scroll. Oh, cool. Yes. All right, I'm also going to start another poll on Discord. Okay, looks like there is a question on Discord. Is there a way to change mouse control settings? I would like the mouse wheel to zoom in and out. Is it right-clicking, dragging? Yes. If you want to access those settings, it would be through the Preferences menu. I don't remember exactly which key, but let me try looking for it. Okay, it might be under System, Mouse Wheel Configuration. There we go. It's so after you click on this gear icon, go to System, and then go to Mouse View Configuration. And here you have the freedom to change the key combinations for everything. Oops.
For this wiring step, is it just this bit that you wired, or like everything in the whole circuit?
Everything in the schematic. Oh, I guess one thing I didn't mention is, let's say when you're wiring and then you want to cut the current wire and go to the next one. We can first left click to sort of place the wires first, and then we can right click once to exit out from connecting this specific wire, and then basically start the next new wire. And if this is established, I can right click again, and then left click to start the next wire. If you want to exit out from the entire command of placing the wires, then you will basically right click twice to exit out from continuing placing the wires. And another useful shortcut key, I guess, is let's say you want to delete the entire wires. So all the wires with the same net, not all wires, the current selected wires that connects with the same net. Then you can first select a portion of that wire and then press the tab key. And then that should highlights the entire path for you. I'm not sure how I can demonstrate it since I can always select the entire portion. But yeah, if you only have a little portion and you want to sort of delete the whole path, then you can press the tab key to select everything. Okay, another question. When I move the mouse, it moves everything. I need to delete a wire. Oh, do you mean? Actually, do you mind sharing your screen? It might be a little bit hard for me to imagine your scenario. Okay, let's see. Yes, what's going on here? Oh, okay, I see. So we want to delete the wires that are connecting all of these pins over here. And I think if you select the wires itself and then press delete, it should be able to delete. Can you try pressing on the wires real quick? Oh, actually, the first thing you need to do is exit out from the place command. So right click once. Yes, now try doing it. Left click on the, yes, exactly. Yes, there we go. Yeah, so in that situations, you can actually add more corners before connecting it to the side. So for example, if I want to connect this pin over here with this pin, I will first start my wire and then left click here to add the corner, move my cursor up, left click again to add another corner, and then move my cursor close to the resistor and left click again. Yeah, so you can add multiple corners while you're placing the wires. Exactly, yes. Okay, another question. The carry out pin should not be connected to the LED. Yes, the carry out pin should be floating. Okay, so that is 10 minutes. Okay, let's see how everyone's doing. 2 volts. Okay, let's try another 5 minutes. All right, got a question. Is there a way to make wheel click drag instead of right click? I do not have a solution for that, but I can try searching for it. So we're trying to. I'm a little bit confused. So are we? Oh, I see what you mean. Yeah, I think in a lot of other software they use the middle wheel click as dragging. That's yeah. I think I know what it means. No. Hmm. Okay. Tools customization. Let's take a look at that.
Oh, out the clock. I was fishing myself out, that's why. Just discharge it for whatever reason.
I would say there might be a way, but I do not know how to do it. I try searching online, but it doesn't give me a correct answer. Hmm. Yeah, unfortunately, I cannot help with that question. Sorry. And navigation. Yeah, I'm afraid there's no way of changing that key combinations for dragging the canvas around. Okay. Let me check the polls real quick. 5 volts, and we have 30 more seconds. Okay, are we ready to move on? Okay. Yeah, I'm just gonna start doing the next step. And if we have more time left over towards the end of the trainings, we can use that time as a free hands-on practice time. All right, so let's come back to this diagram. So we finished how to do the wiring, how to do the part placement. The next step would be for us to perform the annotation. Okay, so at the annotation step, we're going to assign a unique designator to all of these components. I have a question in the chat, how to add VCC. Yes, so to add a VCC, you come to the active toolbar, and there is a divider over here. So you count the third icon from the divider. And I think by default, it should be a ground symbol. And you can basically hover over to that ground symbol, right click, and then select place VCC. And that should give you the VCC symbol. Yes. Okay. So for annotation, we're going to use a tool we call the Annotate Schematic menu. And we can access that menu by going to Tools, Annotation, and then Annotate Schematics. And I actually want everyone to follow the step with me. So it's under Tools, Annotation, Annotate Schematics. After pressing that menu option, it will open up this annotate page. Okay. So there are only two things we have to change in this page in order for us to assign the designators. The first thing is order of processing. You can choose any orders you would like. So this basically specifies the order of increment that we're going to assign to these designator. So for example, if we have a resistor over here, another one over here, another one over here, another one over here. So you have 4 resistors, one at each corner. The first selection is up, then across. That means the resistor values with the smallest designator name would be at the bottom left corner. And then the second one would be the top left corner, the third one with the bottom right, and the fourth one with the top right. So if I select this selection and I have this layout on my schematic, then eventually the designator would be R1 over here, R2 over here, R3 over here, and R4 over here. And the green arrow, it basically shows the orders that we're incrementing these components, designators. Okay, versus if we choose down then across, then the smallest values will be at the top right corner. And then it goes down and then go to the right and repeat this process until we have finished annotating all of the components. Okay, and you can explore the other options as well. But for me personally, for this project, I prefer to use down then across. But you're free to choose any selections you would like, and you can actually change this multiple times to see the effect. Okay, so after we have chosen the order of processing, the next thing we're going to do is to look at this proposed change list. So under this list, it's actually separated into three different columns. So the first column shows the current designator, which are just a bunch of letters with a question mark because I have not changed the designator names for these components. And we can change the proposed column by clicking on this Update Changes List button. So it's going to say there will be 27 changes, and I select OK. Then it will update the proposed designator list on the right-hand side. Okay, so this is a reference tables between the current designator values and the proposed designator values that I would actually accept. And if everything looks good, then I'm ready to click on this Accept Changes button to create ECO. So to sort of go over ECO, so ECO is the thing that we mentioned that's going to synchronize the changes from the schematics to the PCB. It stands for Engineering Change Order. And And at the steps when we are annotating the schematic, we'll also use the engineering change order because we're not only making these new dexinators realized by the schematic, we also want it to be realized by the PCB. Okay, so we'll click on this button. And then it shows this table over here that shows all the changes. So the dexinator for C question mark becomes C1, another C question mark becomes C2, and so on. We'll click on validate changes to make sure that all of the changes will not generate any error. And if I only want to look at the error, I would check this checkbox over here to make sure there's no error. If everything looks good, I can click on execute changes. And we don't have to care about this for now. And then close all the windows open now. And now when I take a closer look at all of these components, you can see that it all comes with a unique dexinator. Okay, so this is a little much more convenient than for us to click on these components and then change the dexinators one by one in the properties panel. We can just use the annotation schematic tool to automatically assign the tools for us. I'm sorry, the dexinators for us. All right, I will give around 3 minutes for this part. And you can feel free to continue exploring what would happen if you change the settings in this window, right? So you can change the order of processing. And you can even sort of try changing the... Oh, sorry, this is for a different training. Yeah, so for this workshop, we will only change the order of processing right over here. And you can sort of test if the current dexinator here is following this order of processing. So because of this order, that means the dexinator's values on top will always be smaller than the dexinator values at the bottom. Right, so I can verify it by looking at my dexinators. So the dexinator over here, they're always small. And the dexinators at the bottoms, they're bigger. Okay, is there also a way to make all of the resistor components to change to their values? Like the resistors on the right showing 1K instead of the part number? Two of my resistors are labeled as R2. That is very strange. Let me first answer the first question. Yes, there is a way to change the comments globally. So if you select all of the components that you want to modify those values, for example, this guy, I want to change it to 1K, then I will first select all the resistors and then go to the properties panel and then change the value right over here into 1K and press enter. And I think that should show, oops, sorry. That is very strange. Okay, sorry, I might have accidentally selected a wire or something. So that didn't give me the right properties panel. Okay, now this is the properties panels I was looking for. So we first select all of the resistors we want to change the values. Then we come to the properties panels and then go to the comment section. And then I would type in 1K and press enter. That way it has changed all of the values into 1K. Okay, so let's move on to Anna's question. Two of your resistors are labeled as R2. Okay, do you mind sharing your screen so I can look at what happens at the annotation schematic panel? Sorry, this is not a panel.
Okay.
This is a menu.
So I got this thing open. It's R3. So I have holding R2, and it skips to like R4. And when I manually change it to like R2, it's like, no, actually it's still R3. And so then I check the annotation thing, update changes list, and you see the two R3s over there.
I have never seen this before. Okay, that's very strange. Really?
I'm gonna press reset all.
Yeah, maybe try doing that. Okay, great. Now do the update changes list. Oh yeah, maybe validate the changes first. Yeah.
Close, update.
Hmm.
Okay, I think
Does it still say that?
hopefully this fixes it. Let's see.
Yes.
Okay, that's R2 and R1. It's wrong, but it's not wrong. It's just weird. But I'll take that, I guess.
Maybe it's the order of processing. Do we have the same order of processing or different ones? Or sometimes it happens if, like, let's say the component is slightly off, so they're off a little bit by off grids by a little bit. And when it's doing the processing, it's processing the one that's slightly to the left and then do the next row. So that may be a potential reason why it does not follow the order.
Because maybe it sticks out a little bit because the potentiometer, so
Exactly.
I understand. Okay.
Yeah. So that could be one reason. Well, mine's a bit weird too. I don't even see my R1. Oh, wait, by the way, we have the same thing, I guess. This is R1, that's R2, and this is R3. Yeah, so I guess it's not that weird.
So,
And it's probably also not solely determined by like the size of the component it appears to be. Like there might be some other, I don't know, like I don't want to say clearance because that's more like in PCB, but it might be realizing the specific components with the size of this big versus the other one that may just be a tiny bit. So yeah, it could be another cause for dexinators not in order. Okay, I got another question. Yes, the error is normal. We will learn how to resolve those errors at next step, ERC. Well, I don't think I know what the first error is for though. We can look at that a bit later. Oh, and I forgot to post a poll. So this is for annotation. Okay. And my timer just died, so I'm going to start a 1 minute timer only. Okay, is there a way to check that all wires are connected? Yes, that's exactly what we're gonna do next, the ERC. Is to validate the schematics. Yes. You're a step ahead. It would be at this step. All right, the last 5 seconds. Okay, cool. All right, now we have all the connections made. The next step would be validating all the connections to make sure we have, we did not accidentally leave anything open or short anything. Okay, so now we're at the ERC step. ERC is a tool for us to validate the schematic design, and it stands for electrical rule check. So to run the ERC to check our schematic, we can come back to the projects panel. Okay, so you can find it somewhere in this in these panels menu, or you come back to panels and then click on project. And that should bring it to the front. Okay. And after we have this project, we can right-click on the project and then select Validate. And it should have this messages window popped up. Sorry, this is the part I want you to sit back and listen. So this will pop up all of the error messages related to the schematic sheet. Okay. You can see that some of them are errors and some of them are warnings. So for error, this is what will prevent you to import all the changes into PCB. So you have to fix all of the error before moving on. But for the warnings, you do not have to. Okay, and there's a way for you to change, exactly what features you want to generate the warnings and what features you want to generate the error. I would not go over it right now, but if you're interested, I can go over it during the practice time. Okay, but let's first try solving this error over here. And I read the message. It says net U1_5 contains floating input pins. So remember, net is just a name that we assign to a signal. So the signals could be associated with a pin, or it could be associated with wires, and so on. Right. So for components, we have dexinators, but for wires and pins, we have net. They're the same thing. Okay. Sorry, they're not the same thing, but same concept. And it's kind of hard for me to locate this net U1-5. So for me to locate this error, I can double click on the specific error message. And that's going to take me to the place where it generates that error. So my ERC is basically telling me, hey, this is an input pin, but you do not have any driving source for this input pin. Are you sure you want to leave it floating? And I check the data sheets and everything. Like, for example, I may be going to this component, and then I go to its port choice, and then I read the data sheet. And then I verify its function to make sure that, this pin is intended to be left floating, or your specific project do not require any connections for this pin. So to suppress that error message in the messages panel, we can right-click on that message. That message entry. Right-click on that and then select Place Specific No ERC for this violation. That just means for this error, please do not generate an ERC. And I will be placing this red cross, which is basically something that will suppress this error, directly onto the pin, just like how I'm making a connection. You want to see a red hotspot around that pin. And there, if I go back to my project and validate the project again, and come back to my messages, now my error message just disappeared, and I have this green message that says the project has compiled successfully and no errors found. That means my project is ready to move on to the PCB layout. Right, so you might have a bit some other errors that you probably won't need to fix. So for example, you may not be connecting some of the pins, or you may be accidentally shorting something. So I will give the next about 5 minutes for you to resolve any error message that pops up in this messages window. And another thing, I guess that could help us to check is, well, no, I will go over it in the next section. Yeah, for this step, just resolve all of the issues in the messages panel in the next 5 minutes. And if you encounter something that you cannot fix on your own, just feel free to share your screen and I can take a look at your schematic as well. Okay, so one more time to validate the project. We come to the projects panel, right-click on that project, and then select Validate PCB Project. And then it should have your project name. Where's my messages? And this is basically what generates the messages panel. And if you click on validate and the messages panel do not pop up, that just means there is no fatal errors preventing you from moving on to PCB. That means you're good. But if you still want to look at the warnings, then you can go back to panels and then select the messages panel. This should still show you all of the warnings here. Okay, so I got a question. I have a bunch of off-grid warnings. Can I just ignore those? Yes, you can just ignore them. So off-grid warning means properties. Yes, so there's a snap grid selections over here. So if the component is not currently snapped to the snap grid size that you set over here, it's going to generate a warning. But it does not affect the electrical connections or the logical connections of the component. So it will not generate any errors when we move on to the PCB. Yeah, so long answer short, you can ignore off-grid warnings. Okay, what does this error mean? Okay, let's see. Duplicate component destinators. Okay, yeah, so that means you have two components with the same component name. So you probably have two components that are both labeled U1. And the way to fix it is to either manually click on that component and change one of the components into another name, or we can come back to the annotation tools, right? So that's tools, annotation, and annotate schematics. You can first reset all of the values, and then basically update changes list, and then accept changes order. So repeat this process again. That should overwrite all of the destinator to avoid duplicate. Okay, hopefully that answers your question. I think I did the annotate wrong. I got a duplicate destinator error with the resistor 1 through 3. Yeah, so actually let me walk through the steps to reassign the destinators. Okay, so to reassign all the destinators, we come to, by the way, normally this type of problems happens as you have some components manually labeled and the other components labeled by the annotation tools. So you either want to only use menu annotation or you just want to use the tools to basically do all the jobs for you. Yes. So to re-annotate, we come back to tools and then navigate to annotation and select annotate schematics. So under this page, I want to click on reset all real quick. It's going to say 28 changes were made from previous date to basically reassign all these changes over here. And now you should be good to click on update changes list. Oh, sorry, I need to, because my version is good, so it's not going to allow me to change it. Oops, sorry. Okay. Let me first apply all the changes real quick. But I think for you, you don't have to do the ECO. You should just be able to reset all and then click on update changes list to have a newly assigned proposed destinators on the right, and then select accept changes to basically reassign those destinators. That should fix the duplicate destinator error. If it doesn't, let me know. Okay, next question, Michael. We have multiple output pins. Most likely that means we are shorting something that we don't want. If you can share your screen, I might be able to take a look at what's happening there. Yes. Okay, let's see. Can you double click on that error message and take us to that error? Cool. Okay. I'm not sure why there are dots around the pen. Usually we do not have any dots. So that could be the reason why. So there might be some misconnections around the pen. So one suggestion I will make is if you can click on this filter icon over here and then press all off or all on. Yes, exactly. And then only select wires like that. Yes, exactly. So now you can only click on the wires and then you can make the modification a little bit easier. Yeah, so try deleting that wire and try deleting the dots. Yes, exactly. And then move it close to that thing. Oh yeah, it's a little dim. There's one more thing that could help with that is let's go to the properties of the document option. So click on any empty space on the canvas and then navigate to the properties panel. Yes, exactly. Scroll. Oh, it's selecting the wire. Is there a way for us to Yes, exactly. So scroll down to see the snap grid. Make the snap grid 100. Oh, yeah. Well, yeah. What's going on here? Press the panels button and then select properties. Yes, exactly. And then we can, yes. Do you see under general, a little bit down? Yes. There's a snap grid section. Yeah, change that number into 100 mil and see what happened. Okay, and enter. Yes, and then now you can come back to continue wiring. Oh, it does not snap anymore. Okay, yeah, maybe change back to 10 then. My bad. That didn't help. By the way, what is the grid I'm using right now? I am using 10 mils too. Okay. I'm trying to figure out how that even happened because it's not doing it for my. Yeah. Okay, try bridging it. Try zooming in super, super close to that edge. Yes. Oh, okay. Yeah, that's the problem. Yeah, make the connection. Yeah, you can. Oh, okay. Well, I guess a better way would be grabbing the place wire tool. It's from the active toolbar. Yes, and then click on the pin first. What's going on? Okay, yes, and press that wire on the right-hand side and see if it works. Schematic. This could be a graphical editing preference to show a dot at all connection. But you do have some connections without the dots though. Yeah, well, yeah, maybe just try connecting it that way. It works. Yeah, and then run the design rule check again. So go back to the projects panel, right click on the project, and validate. Oh, sorry, the project file. I think you just selected the schematics. Yes, that's the project. Did it disappear? Okay, it's gone. I guess we can live with that. Yeah. And what is this error? Contains multiple outputs. So this is a similar issue. So try disconnecting this guy real quick and then make the connection again. I think the reason why we have the dot at the pin is because I remember there's one of the settings here that it's like a visual preference to show a dot at all connections. I do not remember exactly which selection it is, but if it doesn't generate any error, then I think we're good to move on. Yeah, sorry, I don't know which one it is. I can try figuring it out a little bit later, but yeah, so try solving this error and see if it works. Yeah, you do have to rerun the validation to see if it solves the error. Okay, so I'm going to move on to the next students, but I will come back to you, Michael, a little bit. Okay, so I have unconnected line error, but double clicking it won't show me where it is. Okay, Anna, do you mind showing your screen?
Yep. Let me just do that.
Okay.
Okay. So
Mhm.
I have all these warning. I know it's a warning, but it seems different. The only one that's different from the one you have. Unconnected line at 16,400, 6,800. 1, 2, 3, 4, 5, 6. So about here, I guess.
Why is it not showing, or why is it not focusing on the point? 63. What is your grid size?
100 mils.
Per. Okay, cool. So that probably means each divisions would be. Oh, actually, if you look at the bottom left of your screen, there's the XY coordinates, the real XY coordinates of your cursor. So try to move your cursor to somewhere at around.
Oh, that's how I see that.
Yeah.
Oh, is this just off the screen? Oh.
Oh, there, I see the wire. So yes, that thing. If you delete it and then run the validation again, that should resolve.
Thank you.
Okay, cool. Yes, no problem. Okay, cool. I'm glad that I can at least fix something. Okay, Nathan's good. Okay. All right, so do we all have resolved errors? Did a forced annotation works? Okay, cool. Oh, I'm so sorry. I think I've been calling you Michael. I'm sorry, Michelle. Did you resolve the error that you saw? The original one is not resolved. Okay. In this case, let's move on to the next step, and then at the next practice, I will come to resolve your issue because the next step does not need us to pass the ERC. So, Michelle, I'm going to come back to you after this presentation. Okay, we will resolve it together. We'll definitely get it. Okay, so bring back to this map over here. All right, we just finished validating all of the changes, or sorry, all of the errors in the schematic. Next, move on to adding the CAD's nodes. Okay, so this is the step for us to add a little bit more annotation, sorry, not annotation, documentation to our schematic. So for example, if you want to sort of place some notes related to the functions, features of this schematic. So let's say I want to explain to the PCB designer exactly what is this header doing here. Then I can use this tool over here, place text string, to place a text right next to this connector. So I want to say something like 2-pin connector for external source. And then I can change the style, the size, the color of this text. And boom, it becomes much more clear on, exactly what is this part doing. And I guess another thing we could also do is to place rectangles that sort of visually divide up the schematic a little bit. Right, so for example, I would pick this rectangle. So this is by the second from the last icon over here. If I right click on it, I can access much more drawing tools compared to just the one at the active toolbar. So for example, I may draw a box over here. So this is the oscillator logic. And then I can make this box transparent. Can adjust the size a little bit. And then I will add another header over here that says, okay, for the components in this specific box, this is the timer logic, right? Because all of these capacitors, resistors, over here, the potentiometer, it's just for adjusting the frequency of this timer. Right, so this entire block represents the logic for the timer. And put down another block over here. So this represents the counter logic. Oh. And then you can basically place another block over here that says this is the LED logic, right? So you can use text, you can use lines, you can use ellipses, rectangles to visually divide up the schematics and give more visual cues for the other engineers or for the person who is going to draw the PCB. So this may probably means they want to place all the parts in the specific box in one region on the PCB and all the other parts on another region on the PCB. Okay. Does it make sense on how to add the nodes into the schematic? Okay, cool. Let's give around 5 minutes on this. And then I will just work on resolving Michelle's error. Okay, I will also post a question here. Need more time. And this is for notes. Okay, let's see. And that's a very interesting problem that's happening. Okay, let's try zooming into the parts where it generates the error. Okay, it's this guy again. Do you mind reselecting the filter so we're only selecting the wires? Yes, thank you. Contains multiple output pins. Okay, let's highlight this entire net because it might not be this connector. Can we see the other parts where this wires may be connected to? Okay, cool. Can we try just deleting this entire path? Okay, and then redraw it, but starting from the left-hand side, exactly. And then move it to the right. Why is it keep generating that dot? Okay, I don't know, maybe try running the validation real quick. And I will search for why there is a dot. Still there. Oh yes, try pressing on the other pin. What is the first? Yes, try pressing on the first pin again. What is this pin? U1 and U23. So I'm assuming your U1 is this guy over here, and U2 pin 3 is this guy over here. So that means this pin here and this pin here. There's a short. Okay, let's zoom out from this window a little bit more. Okay. And we can close the messages panel. I think I know what the problem is. Okay, which one is your U1 and which one's your U2? Sorry, the box makes it a little bit hard for me to see. Maybe the screen is a little bit better. Okay, cool. So that guide is U1. Okay. The part on the right is U3. Can you give me a favor to basically delete U1 and then place the 555 timer again? I'm not sure if it's going to fix it, but looks like all the dots there are only connected to the U1 part. So I'm assuming that could be. Oh, okay, sorry. This is U2. Wait, then what is U1? Oh, I think I know what the problem is. I think you have two components right on top of each other. So you have U1 and U2 right on top of each other. So yes, go back to the selection. Yes, and then press component. Or yeah, that works too. Yeah, you don't. Yes. Okay, cool. And then press on one of the yes and delete one of them. That's why. Because we have two components on top of each other. So we're shorting to the 555 timer. That's cool. Okay, a question in the chat. I will come back to you, Michelle, a little bit. Okay, so a question in the chat. How do we get the larger text bold? Okay, yes. So you click on the text object and then go to the properties menu. And then it comes with these properties for you to modify. So you can make it italic, bolded, or underlined, and so on. And if you want to make it a little bit bigger, you can change the font size here as well. Okay, that's 5 minutes. Okay, cool. Michelle, do you need any more help, or you're just fixing those two parts? Okay, let's give another 5 minutes for everyone to finalize their design. Okay, cool. Thank you. And for people who are finished, feel free to use the time to take a break. And starting from now, we're going to actually do the PCB layout. I'm not sure if anyone's wondering why the screenshot I shared it comes with those red and blue colors on the net. So this is something you could also do to annotate your schematic as well. Let's say I'm in particular interested in looking at all of the wires with the power net and all of the wires with the ground net. Then I can go to the view menu and then select set net color. And then you can choose whichever colors you prefer. I usually do red for power and then, red for VCC and then blue for ground. And I select the color, basically click on the net. And all of the nets that shares the same signal, so like all of the wires that shares the same net will be highlighted. Okay, so I guess this is a really quick ways for you to also check if you have make all of the connections between the powers and the ground. Right, if the colors, the highlighted colors does not match with the one that I sent on Discord, then it means you probably forget to connect certain things or you do not connect the power or the ground correctly. Okay, so that's just another way for us to annotate or add nodes to our schematic. So go to view, set net colors, and then choose the color you would like, and then basically left click on the net you want to highlight in. couple more minutes. Okay, I saw Michelle just shared her screen. Okay, cool. Did we resolve all of the errors? Okay, let's try validating. Yes, if the messages panel do not pop up, that just means you pass all the tests. But if you want to look at the warnings, you can still press the panels button and then press the messages panel. So at the bottom right, press yes, and then press messages. Yep. Yeah, cool. You have exactly the same thing as mine. Awesome. Okay, so that is time. At this point, I think this would be a really good time for us to start saving or pushing off the changes back to the server. So I'm going to do Control S to save all the changes locally, and then go back to my projects panel and click on Save to Server. Okay, because this is where I just finished schematic drawing, and press OK. Right, so it just saves all of my changes back to Altium 365. Come back to this globe icon over here to open up my workspace. And now I should see my schematics on Altium 365. Okay. So I just find it kind of necessary to do it right before we convert all of the changes into PCB, because we want to save a copy of our current project before we move on to something a bit more complex. Okay. Now let's look at how we can package the engineering change order and basically import all the changes from the schematic into PCB. You can sit back and listen for this portion, and I will give you some time to perform the step, but this is where we're at right now. Okay, to convert a schematic into PCB, we can first go to the PCB document we have created earlier, and then click on Design, and then click on Import Changes. So Design, Import Changes. So this will generate the ECO again, Engineering Change Order. If you're interested, you can sort of read these entries that says add this component C1 to PCB, add another component C2 to this PCB, and so on. They do it for all of the components and also all of the nets, right? So that's their unique name that we give to a signal, and the signals could be carried through a wires or through a pin of a component. Everything looks good. I will validate the changes, If there's no error here, we'll be ready to execute the changes. Okay, this way, I not only have this PCB over here, I also have all my components in my PCB. All right, so everyone take about 3 minutes to perform the ECO. And let me know if you encounter any error when valid. Yes.
What button did you press?
Design and then import changes. But you have to first focus on a PCB document. So open up the PCB document and then go to design and import changes. Or we can type it in the chat. That is the time. And okay, any question in the chat? Nope, we all got the components in the PCB. Cool. All right, now we can finally move on to the PCB workflows. So we just finished all of the steps for schematics. We have established the logical connections for our circuit. Now we want to establish the physical connection of the circuit. Okay, so in the next presentation, you will also be sitting back and listening. And I'll be going over these two components together. So the stack up and the board outline. Because I feel like they kind of go together a little bit as well. And we don't need to do anything for the stack up. Okay. First, before we start doing anything in PCB, I will give you a short introductions on the different sections in this PCB document and some of the navigation skills that could be helpful when we're drawing the PCB. Okay, so when we're looking at a PCB in Altium Designer, there are actually 3 different ways for us to look at this PCB. So you can access all 3 different display modes by pressing the number keys above your letter keys. So I'm not sure what happens if you press on the number keys on your keypad, but I can guarantee that it will work if you press the number keys above your letter keys. Okay, so you can use number 1, number 2, and number 3 to access the different viewing mode. If I press number 1, this brings me into the board planning mode. So in this view, we're not going to go over in this workshop, but this is usually the modes that people use to establish Flex PCB. So Flex PCB, they're just a type of PCB that's flexible. So for Flex PCB, some regions may be flexible, the other regions may be rigid. And this is the modes that people use to determine those rigid region and the flex region. But for this training, we're not going to go over how to define Flex PCB. So we will only be using the later two modes. So after I press number 2, that brings me to the 2D mode, which is the default modes that opens up after I've created a project. And if I press number 3, this brings me to the 3D mode. So I can not only look at this board in 3D, I can also look at all the components in 3D as well. Okay, so number 1 is board planning, number 2 is 2D, and number 3 is 3D. In 3D viewing mode, if we want to rotate this board a little bit, we have to hold the Shift key. It will open up this orb over here. So this will allow 3 different types of rotation. We have rotation around the Z-axis, which is by the circle. We also have rotation by the X and Y axes over here. The last one will be the free rotation, which is by the dot over here. So what do I mean by that? Okay. So let me hold the Shift key real quick and demonstrate all 3 different rotation. To sort of move or rotate freely, I can hover over my cursor to this dot over here in the center, hold my right mouse button, and then start rotating. So this is free rotation. If I want to rotate around the Z-axis, I can press Shift again, hover over my cursor to the circle. Any one of these 4 will work. And then hold my right mouse button and then start rotating. This is around the Z-axis. If I want to rotate around the Y-axis, hold the Shift button again, move the cursor to these 2 arrows, either one will work, hold the right mouse button, and then start rotating. And lastly, around the X-axis, we just need to hover over our cursor to the top and bottom arrow, and then rotate by moving the mouse. Okay, so that's how we can rotate using this orb. First of all, press the Shift key, and then move the cursor to any components you would like, and then hold the right mouse button to rotate. The action not available in 3D error. I'm not sure how that error is generated. Let's look at that at the practice time. I'm interested in knowing what's going on there too. Okay, yes, but other than using this orb, we could also use some of the number keys above the letter keys. So for example, if I press number 8, this will give me this particular view. And then press 9 would basically rotate the boards by 90 degrees. And pressing 0 will bring you back to the original view. Oh, cool. We have a solution there. Pressing the left key. Yeah, so the left key gives actions not available in 3D. Interesting. Yeah, we do want to use the right key. Okay. Yeah, so a lot of times when I'm like sort of rotating these things and then I got into a position where I just cannot rotate back to the original, I just need to remember to press 0. And that brings me back to this flat view. So try the different number keys during the exercise time to see what they would do. But most of their functions should be rotating this board in different orientation. Okay, so that's enough about the 3D view. We'll be doing most of the designs in 2D mode, so press the number 2 key to bring us back to this mode. It's a very similar layout as the schematics. You can still be holding your right mouse button to drag, and hold the control keys and then scroll the mouse view to zoom in and zoom out. And of course, for this particular PCB document, we also have the properties panels, and you could see that the properties panel is a little bit different compared to the properties panels for the schematic. It shows the surface areas, it shows the total components we're going to place on the board, and it also shows the densities. What it means is, if you place all the components on top of the board, it will only take up about this percentage of the surface area. Okay, so the properties panels of the PCB board actually gives a lot more information. So other than the properties, the active toolbars, we also have these layer tabs over here at the bottom. Okay, so they might look a little bit intimidating at the beginning, but don't worry, they're things we have seen before in the presentation. So let's come back to my slides. Okay. So this guy over here, it comes with a dielectric layer, a top copper layers, and the bottom copper layer. We don't really have any freedoms in sort of cropping out any portions of this dielectric layers, but we can draw the signals, we can draw the wires on the top copper layers and the bottom copper layer. And this top layer and bottom layer tabs at the bottom here, they represent the top copper and the bottom coppers that we saw in the earlier image. If you're interested in knowing which one would be in charge of printing off the dexinator, that would be through this top overlay layer. Okay, so to give an even clearer picture, I'm going to pull out the layer stack manager over here. So this menu over here shows the stack up of my board. Okay. Okay. So the board we're designing is a 2-layer board because it comes with a top copper and a bottom copper, and there are only a total of 2 copper layers in total. So we call this a 2-layer board. And of course, we have to have a dielectrics layer in between of those 2 copper layers. And then remember the scratch R scenarios, where after the etching process, we want to apply a protective layer on top of the copper layer. So we actually call that the solder mask. The solder mask is the green thing that you saw on top of the PCB. So everything green on the board, that means it has a layer of resins cover on top of it. Everything silver on the board, they're just exposed copper layers. That's exposing the layers that's underneath the resin. Because we still need to expose some of the copper layers for us to make electrical connections between the components and the board. Okay, so the green parts means the solder mask, and the silver part means the exposed copper layer. And on top of the solder mask, we also have the overlay layer. So the overlay layer specifies the acrylic paint that we put on the board. So that's how we print the dexinators and how we print the messages that we want to specify on the board. All right, so in short, the dielectric layer is the insulating layers in the middle. The copper layers is what we would draw the signals for us to connect the components together. The solder mask layer is a protective layer for the copper layer. And lastly, the overlay layer is the acrylic paint that we put on the board for dexinators. Okay. And now we know the functions of these layers. We can look at the name for these layers when we're drawing this PCB. So for example, if I'm looking at the top overlay, the overlay layers for the top side, that is represented by this top overlay layer over here in the tab. The solder mask is by top solder, and we should be able to find the top solder layer somewhere over here. Can't find it. Oh, right here. So this is the top solder layer. Okay, and we also have this signal layers, which is the top layer. So this is the top copper layers where we draw the signals in this top layer tab. Dielectrics, we don't really draw anything on top, so we do not have a dielectric layer tab. And then with the bottom layer, so this is the bottom copper pad. The copper layer that's underneath this dielectric by this blue color over here. And then of course, we also have to apply the resins at the bottom side of the PCB. That's called bottom solder, which is this layer over here. And then we also have the bottom overlay. So the bottom overlay is what the acrylic paints that were applied to the backside of the PCB. Okay. Hopefully that helps you to understand the stack up a little bit better. So stack up, again, it's like the recipe of the PCB, right? If you think of it as a burger, this is the bread of the burger, this is the sesame on top of the burger, and then lettuce, whatever, right? Same thing here. It's just layers after layers after layers. Okay. How did I show the panel? Yes, you can access this by going to Tools. Oh, sorry. Design. Yes, by going to Design and then Layer Stack Manager. And for more advanced design, you can even insert more layers on top and bottom. This is how you can create board PCBs more than 2 layers. Yeah, but for the purpose of this training, we're not going to go into too much details about that. We're fine with using a 2-layer board. Yeah, but if you're interested in exploring this feature, right, again, you can access the documentations by pressing F1. This will pop up a documentation for layer stack. Okay, hopefully that's helpful. All right. So we're still in the middle of going over the PCB design environments, right? So we look at the active toolbar, we look at the properties panel, we look at what these tabs at the bottoms mean. And next, what I want to show you is how to define the shape of this PCB. Okay, so for drawing the shape of the PCBs, you probably want to do this step either early or super late, because let's say you already have a dimension in your head, then you probably want to crop out or define the board shape first, and then see if we can fit all the components on top. Or if you do not really care about the size of the board, then you can do this after you have fit all the components on the board. So now I'm sort of going over the scenarios where you know exactly where to place this PCB, and you have a specific size in mind that you want to set. Okay. So to redefine the shape of this PCB, we can use the tool over here to draw a rectangle. So the tool would be through this last icon. I can right click on that and then select rectangle. And then I can basically draw any rectangles I like. But the idea is after we have drawn this rectangle, we have to come to this properties menu to edit where I want to place this rectangle, and also the size of the rectangle. So normally when we're drawing lines, that's just for reference. For example, doing the board shape, this is just for reference. It does not carry any electrical information. So I will avoid placing it in any layers that's specified in the layer stacks, because they have something to do with electrical connections. Right, so normally we would put it in the mechanical layers. And over here, by default, this project should have mechanical 1 layer. Okay, and I would also change the size a little bit. So you can define the shape, or sorry, the size to be anything you would like. I would just make it 37,000 by 17,000. Okay, then I have this reference line for my PCB. The next thing I need to do is to come to Design, Board Shape, and then define board shape from selected object. This way, I have redefined the shape of the board. Okay, yes, so it's the last icon over here. Similar to when we're drawing the rectangles in the the schematic. Okay, so I think I covered enough for now. So I will give you around 10 minutes to explore the features I just mentioned, and I will place all of the path to reach those features in the chat. Okay, so for the layer stack, you want to go to Design Layer Stack Manager. Okay, what did you do for the last part? Yes, so I redefined the shape of this board. So before it was much bigger, but now it's a little smaller. And you can do that by first drawing a shape in the mechanical layer. So drawing a shape here, and then I have to come to its properties panels for the specific rectangles to change the layer I want to place this rectangle in. So because this is just for defining the form factor, it does not have anything to do with the electrical connections, then as a good practice, we want to put it in the mechanical layers. So I would select mechanical ones as the layer, and then change the width and the height over here. And after we've changed those heights and the width, you can come back to design, and then board shape, and then define board shape from selected object. I will place this path in the chat as well. So board shape, define board shape from selected object. Okay. Yes, so that's basically how we can change the shape of the board. You can try with different shapes as well, like you don't have to do rectangles. Maybe we could try a full circle and change its layer to mechanical one. And then go to design board shape and define board shape. And this way I have defined my board shape to be a circle. Okay. If you want a reference about the size of this board, mine is 37,000 mil by 17,000 mil. Okay, and that should be enough information. Okay, I will also release another poll on Discord to collect feedback. Oh, stop. Sure. Okay.
Okay.
So what the step is doing is basically for you to enclose a shape, an area, and then define the board shape based on the reference line that you drew in the mechanical layer. Sometimes people even download DXF files. So DXF files, it's like, I forgot what the exact name for those files are. Dot array define or something. Yeah, but you can also import a really bizarre shape into Altium Designer. For example, you can make the board looks like a cat or like a flower or something. So that's another option as well. You can also use the line tool to draw an enclosed shape. Something like that, and then select all the objects, put it in mechanical layer 1, and then change the board shape based on this shape as well. That's another way of doing it. And for students who finished, I will share several links in the chat, on Discord, about the manufacturing capabilities of several PCB vendors. Because our next step is about setting the design rules. Okay. A couple more minutes left. Okay, time's up. Okay, so hopefully everyone has already explored the layer stack menu and have a better understanding about these layer tabs at the bottom. The next thing we will do is to set the design rules for our PCB. So it's at this step over here. This is the part where you can sit back and listen again. So for us to set the design rules, remember we have to set the rules because there are some manufacturing constraints that we have to follow that comes from the PCB manufacturer. And I have posted 3 links on the Discord channel. It is under the announcement channel over here. Right, so one of them comes from Oshpark, another one comes from PCBWay, and the other one comes from JLC PCB. So these are the companies, and also there are a lot more other companies out there that can support manufacturing PCB, printed circuit board. And I will just look at this one over here. Let's go to Oshpark. So for this particular company, they have a lot of specs, of course, but most importantly at the step, we want to pay attention to the limitations it has on the traces. So traces means the wires that we put on the PCB, and also on the holes. So the holes relates to the drill size. Okay, so let's look at the traces first. So for this particular company, it says that I can only generate 2 traces with a distance 6 mils or larger apart from each other. So what it means is I will be placing these wires on the boards, right? But I cannot place them any closer than 6 mil because of the manufacturability presented in real life. Okay, so not sure why this project's open. So coming back to here again. So let's say later in the next step, we're ready to start routing the components, but we need to place the wires. We want to make sure we do not place any 2 wires or even the wires between the VS2 or the through holes anywhere closer than 6 mil because it's just not manufacturable by the specific company. And different company comes with different standard, right? So it all depends on which companies you use and what their standards are. Other than that, it also says the width of the wire cannot be smaller than 6 mil. So you can make these wires as thin as possible, but you cannot make them thinner than 6 mil. Okay, so that's another thing that is specified on this website. So moving on, if we look at the drill hole size, so it says the minimum drill size is 10 mil. That means the minimum size of holes that they can drill is 10 mil. And coming back to the board again, so some of the holes that are included on our PCB includes the through holes we have to use to insert the through hole component. That just means the size of these holes cannot be smaller than 10 mil. And also the vias. So remember, via is the tunnels that helps the signals to travel from one copper layer to the other copper layer, right? It's like the trains underground. It's a tunnel that helps the train to go from one level to another level. We also need to make sure these vias, so they're essentially little holes as well. So we need to make sure the hole size of the via is not smaller than 10 mil. Okay, and there are a lot other specification you have to follow or be careful about when drawing the PCB. And you can find all those informations through the company website. Okay, so I have posted 3 different companies for you to explore. And now I actually want to give you about 4 minutes as well to look at those websites. And I will post in the chat on the things that I want you to look for. So first of all, you want to look for the hole size, which is the VS size. So minimum hole size. And second, I want you to look at the minimum track width. So this is the width of the wires. And third, I want you to look at the minimum distance between two objects. So the objects could be these vias, they could be these wires, anything you can place on a PCB. So we call this the component clearance. Okay. So read through so kind of skim through all three websites to get an idea about some of the constraints we have to follow when designing the PCB because of manufacturability. And the links could be found over here under the announcement channel. Last 30 seconds. right, time's up. Okay, so hopefully you get a general understanding about some of the constraints that we have to consider before we can start placing the components and making the connections using the tracks. And I'm not going to set any rules at this step. Instead, I will be setting the rules while I'm doing the part placement and the routing so you can see directly the effects of the rules we have set. Okay, so next we will be moving on to part placement, right? Because in schematic, we place the symbols onto the schematic. Now in PCB, we're placing the footprints onto the PCB. Okay, and don't worry if you do not find the answer. I'm going to give you the answer a little bit later. Okay. All right. Now let's start with component placement. Let me first place all of these parts a little bit more to the left so it's easier for me to see everything. I have defined my board shape. Now pretending that I'm the engineers who did not draw the schematics, but now I'm trying to understand the schematics and then want to place the components on the board. Okay, so I might be reading the schematics and saw that, okay, most likely I need to put this connector at the edge because that's for connection with the external source. And I will be probably placing this potentiometer, capacitors, and resistor, and this 555 timers at one regions of the PCB because that represents the entire timer logic, and so on. Okay, and then with a better understanding about where we should be placing everything, it's usually helpful, at least for me, to separate those documents out into two sections. So I may have the schematic at the bottom and then the PCB on top. So something like that. Okay. And before we place these components, and we have already read of the capability for the manufacturer, I know that, for example, there's one entry on the website says you cannot place any two components any closer than 15 mils. Okay, so, oh, sorry, 10 mils, actually, the example I give. No, sorry, they cannot place it any closer than 10 mils. So just to be safe, you'll be setting an Altium designer that you don't want to place any two components closer than 15 mils. So you have that 5 mil tolerance if anything goes wrong, right? So how to prevent us from accidentally placing two things closer than 15 mil? We'll have to use the PCB rules and constraint editor by coming to the design and the rules menu. And no worries, I'm going to place these shortcuts, sorry, the path in the chat later. And it will just bring out these massive menus over here that allows us to set the rules for different constraints. The ones that we're interested in is the distance between any two objects. So we usually refer to that as clearance. So clearance just means the spacing between any two objects. And to specify the minimum clearance, the minimum space that we want for this PCB, you come to design rules and then expand the placement menu and then expand the component clearance. Okay, so these are all of the rules and constraints that the DRC is going to check. DRC is over here. So design rule check. This is the checker for our PCB design, just like how the ERC checks for our schematic. The DRC checks for the PCB. Okay, so by default, the design rules and constraint manager, they already come with some default rules, right? So if you expand, I think most of the settings, they should at least have one rule set. For example, this guy over here. The ones that are not set, that means they're not necessary. Okay. But for the component clearance, it does come with a default setting that says between any two objects, because the scope is all. That means check all of the objects against all of the other objects. Want to make sure the minimum horizontal clearance is 10 and the minimum vertical clearance is 10. That's the default rule. But let's say I read on the website from Oshpark, JLC PCB, wherever. They said, okay, our clearance is 10 mil. But me as the designer, I just want to be safe. So I would add a little bit more tolerance here and says, okay, let's make the minimum distance 15 and 15. So I know for sure it would not generate any error after I've submitted my files to those PCB vendor. Okay, and that's how I can set the rules. Okay. So what it means is, now if I place any two components close to each other with a distance less than 50 mil, it would generate an error. And when you see an error in the PCB, they would just highlight the components that has an error with light green color. Okay, so now these two components are in light green, and we can usually, if it's a clearance issue, if a spacing issue, if you zoom into close enough, it will usually show the dimensions or the distance between these two components. And it says currently it's a 6 mil, which is less than 50 mil. Right. So we know that if I submit this design to a vendor, they might have an issue about manufacturing this specific portion of the board. Right. If I move these two components away from each other with a distance more than 15 mil, then the DRC goes away. They're not highlighted in greens anymore. Okay, so setting the rules helps us to prevent from placing two components too close to each other. And we set it by using the clearance rule. Okay, and after that, we're ready to start placing these components. Actually, not just these two components, we're ready to place all of the components. And you may be wondering, what are these lines that are connecting these pads together? Well, these are the lines that are specified by the net. So remember the net, it's something we defined in the schematic. And then it's basically a unique name that we give to a pin or to a wire that carries the same signal. So for example, this wire here, it carries the same net as this wire, and it carries the same net as this wire, it carries the same net as this wire, because they're all carrying the 5 volt or the VCC signal. Therefore, for all of the corresponding pads of these pins, they will be interconnected by these faded line over here. That sort of give you a visual cues that later on we have to make connections between these legs. Okay, we'll be doing it for the next step. For this current step, we'll be just placing all these components onto the PCB. Okay, and anytime we make a validation, you should be able to see it very clearly that the components are highlighted in green. So similar to when we're placing the components in the schematic, we can also change the grid for the board to make the alignment a little bit easier, right? So currently the snap distance is 8 mil. I usually like to set it to 100 mil. So it's easier for me to align. Okay. And other than that, you can basically follow the pictures that is sent under announcement channel, so this picture over here, to start placing of the resistors, LEDs, potentiometers, and the chips in place. If you want to rotate the part, you can hold the component and then press the space bar. And I think that's everything I have to say about this portion. Do we have any question? Oh yes, rotating the piece. You have to first hold on to the component and then do the rotation. Yeah, at the beginning, I thought I could still rotate if I just have it selected, but you do have to hold the component. And I guess another way to do it is to select the component and then come to the properties menus, and then there's a rotation. There we go, the rotation values. You can also set more precise rotations here as well. Okay. The line changes. Yes, that's totally normal because it will only show the lines that has the shortest distance. So for example, this pad over here may be connected with this component, this component, this component, and that component. But instead of drawing 4 different lines, it will only draw the line to the component that has the closest distance with it. So that should be the optimal way. Theoretically, that should be the optimal ways for us to draw the tracks. Yeah, so if the lines are changing, that's totally normal. Cool. Okay, awesome. Right, let me set a timer for 10 minutes. Well, actually, I think 8 minutes should be enough. This is not too much to do. Okay. And I will also be placing the components with you guys, and I will also post a poll on Discord. Okay. Placement and PCB. And let me also give you the shortcuts to define the rules for component clearance. So we want to go to design rules. And then we go to design rules. Placement, component clearance, and then component clearance. And in the menu, you want to set the horizontal and vertical clearance to both 15 mil. Okay, hopefully that's enough instruction. And if not, I can always demonstrate it again. There's actually another quite advanced tool here that we could use when placing the component is, okay, let me answer the question first. Just one question, how do I change the grid size? It looks different than the sheet. Yes, so to change the grid size for the PCB, you can use the shortcut key G. So if you press G, it should come up with these settings over here. So these represents the grid values you can pick. Or if you want to customize the grid, then you can basically click on any empty space on the PCB and then go to its properties panel, make sure it says board. And then if you scroll down, this just says snap distance right over here. So this is another way for us to change the values as well. It also comes with drop down menus for you to select the size. Yeah. Cool. Okay. Yes, so the advanced feature I want to mention is something called the cross select mode. So what it will allow you to do is if you have this mode enabled, then everything you click on PCB will be highlighted in the schematic. So let's see what it does. So tools cross select mode, let me post it in the chat. Select mode. So I first have to enable this feature. Right now, there's no we usually have a box that's surrounding this icon, but if it does not, then you can click on that icon, and now it comes with a blue box that encloses the icon. And what it would do is, let's say I want to place this DS9. And it will always be nice for me to know exactly what is this DS9 on my schematic. So after I've selected DS9 in PCB, you can see DS9 in my schematic is highlighted. I can do the same thing for other components. If I press DS10, now DS10 is highlighted in schematic. If I press R3, now R3 is highlighted, right? So this is a huge advantage, especially when we have these boxes enclosed. If I have selected a component and want to start placing on the board, I can get a general sense of, exactly where this component is placed in schematic and where I should group this component with the other ones that are enclosed by the same box. Okay, I got a question. So enabling the cross-select mode would help us to reference the components between schematics and PCB. You don't see the grid size in the properties tab. Is it called something else? It's called snap distance. And the grid size, it's actually modified by this grid manager over here. Yeah, we can for sure also change the grid step. Let me try to phrase this a little bit. Okay, so the way that these lines are shown on the board, it's controlled by this grid manager versus the positions that the components could be snapped to. as determined by the snap distance. So if you want to change the visibilities of those grids, then you want to double click on the selection over here on the grid manager, and then change the step size over here. So this would change the visibilities of the grid. Versus the snap distance over here, this will control where your components can snap to. So I'm gonna post a screenshot of both features. Okay. All right, and let's say I want to change my grid into 100 mils. So let me try placing step X into 100. You can see that I changed my the grids that comes with the board. But the thing that exactly controls where we can snap to, that is determined by the snap distance. Right over here. So because I've set both the grid to be 100 and the snap distance to be 100, that's why right now my component looks like it can only be snapped to the grid. Okay, cool. Oh, I see. I'm sorry. I think I asked the grid question. I mean, you asked the grid question and it answered you the snap question, but it's actually related to the grid settings. I hope that clears up a little bit more. Good. We have to change the grid. Okay. All right. I will also be placing these components. Since I still need a little bit more time, let's give another 4 minutes. Yes, you can rotate a part by first holding on to the part. So hold on to the left mouse button and then press the spacebar. Or you can directly select the part and then go to its properties panel to change its rotation angle right here. How did you do that cool place thingy? Oh, you mean placing the components one by one? Yes, so this is something that you can do by, I can show you an even cooler thing. If you open up the PCB document, PCB panels and select component under this drop-down menu, it helps you to quickly select the things that's both either inside the board or outside the board. And in this case, I want to place everything outside the board onto the board. Then I will first check the select box and then click on outside board component, right? So this will help me to select all the components off board. And then I can go to tools and then component placement and reposition selected component. And this way, it's going to help me to just place the components one by one onto my cursor after I've placed the previous one. Something like that. Oh, it's 4 minutes. I think this is the last one. Okay. Got a question. All my stuff is normally barely off grid and won't go back. I can stuff down the grid size to align before shifting back to 100. Is this a better way to do it? Something I would do in that situation would be first move all the components off grid and then set the grid size and then place it back to the boards one by one again. So this is sort of why we want to set the grids before we start placing the component. Or let's say, I'm trying to fix the orientation or the alignments of these things, right? Because they looks like, even though they're on grid, but they still looks like they're not aligned. A really cool tool that could help us to quickly sort of organize all the parts is the alignment tools in the the alignment features in the active toolbar. Okay, so let's say I want to put all of these LEDs in line. I can first select all of the things I want them to be aligned with each other, and then come to this alignment component over here, align component. This should be the last icon before divider. I can right click on this alignment tool and say something like, hey, I want to align all of my components based on the component that's the topmost, right? So in this case, it would be the DS1 and DS10. After I click on align top, it helps me to align all of the parts to the top with the topmost component. And I will show you something that's even cooler, is if you come back to the same icon, you right click on that, and then we select distribute vertically. Oh, sorry, my bad. Distribute horizontally. Okay, so this will fix the spacing between all the parts. So you do not have to make the measurements to look at, okay, this thing must be exactly how many mils away from the other. And then, do it one by one. You can basically use this tool to help you to work with the spacing. Yeah, so this is another way of solving your issues without messing around with the grid. Yes, I know. And you know what's even cooler? Is I can do the same thing for the resistors as well, right? So I'm going to do that trick real quick. Right, so let's say now I want to place all the resistor directly underneath, at the bottom, to the bottom of the LEDs, right? I could just try really hard to sort of align it and I have to adjust my grid, and that's just a lot of pain. Well, one thing I could do is to set the X coordinate of this resistor to be the same as this component, and the X coordinate of this component to be the same as this component, and then applying the same trick I just used. right? So let me first select this guy, the DS1, and I read that its x coordinate is 3400 mil. Right, let me try applying the same thing for my resistor. Looks like it's already there. Okay, so same thing for this guy. For the DS10, it's 6500, and this is also 6500. Okay, so I have this resistor aligned with this LED, and this resistor aligned with this LED. Okay, I want to bring this guy down a little bit more, so let's make it, oh, 2000 maybe a little bit too much. 2050, let's try that. Okay, so that's a reasonable distance. Now if I've selected all of the resistors, I use the tool again. I want to first align everything with the top, right? So it will align off the resistor with the topmost resistor. And then I use the tool again to say distribute horizontally. This way, all of the resistors are spread out evenly based on the leftmost resistor and the rightmost resistor. Okay, so you don't have to worry about adjusting all of the x coordinates or adjusting the grid. Hopefully that's helpful. Yeah, I usually don't mention too much about more of the advanced features because what I found is it would confuse people even more. But yeah, if you're interested in anything I'm doing, I'm happy to talk about it. Okay, so do we need a bit more time at this step? I can give another 5 minutes. Let's start doing that. And after this step, we only have the routings and the fabrication output files, which should be pretty quick.
Beautiful. Okay.
Oh, I can also give you the shortcuts for repositioning the components. I think it's the one I showed a little bit earlier. So tools, component placement, reposition selected components. Component placement. Reposition selected components. There we go. How did you make it so my ground and power connections are colored? Yes, so I made it by highlighting them in my schematic. Where's my schematic? Project, there we go. Over here. Okay, so to highlight the powers and the ground, we can go to the view menu and then select the set net color. So you can pick any colors you would like. In my case, I pick red for VCC and blue for ground. And after I've selected that color, I can just directly click on the wires that I want to highlight. So that highlighted color will actually carry from the schematic to the PCB. So if you have a wires highlighted in schematic, the pad, the corresponding pad, and the corresponding net will also be highlighted using the same color in PCB. So just one more minute for placing the components. When I said the colors for VCC is not visible, okay, try pressing on F5. And see if it shows the color. Oh, so it's highlighting in your schematic but not on the PCB. Okay, cool. Then that means you can focus on focus on the PCB and then go to design and then press import changes and see if that works. It should generate an ECO. Okay, so I have someone sharing screenshots. Oh no, I think it's highlighting. It shows blue, but the VCC red color is not showing. Okay, try going to view again. Oh, I cannot see the pop-up from view, but there should be a set net color. And pick the red color. And then press on VCC. Okay. Cool. I think it's also highlighted in your PCB as well. That looks really great. Yeah, good job on placing all the components. That looks awesome. Okay, so since time's up, now we can move to the most exciting part, which is to make connections with all of these components. Yes, yeah, no problem. You're welcome. Okay, so now we don't really need the schematics because we have already finished placing the components. We can basically tell how to make the connections by reading these net lines over here. Okay. So similar to what we saw before, I'm going to bring this picture back again. Before we do the part placement, we set the rules for the clearance between the two components, right? So now when we're setting the routing process, we actually need to set two different rules again. So the first rule would be the minimum width of the wires, right? Remember, that's the minimum track width. We cannot make the width of the wires to be anything thinner than 6 mil. And another thing we just set is the is the size of the holes. So those are usually referring to the VS. So the VS is it's the tunnels that transmit the signals from one layer to the other layer. But they're essentially just holes, and then you apply some coppers around the holes for it to sort of do the signal transmission, right? So we want to specify the size of the holes, and you also need to specify the width of the wires. Okay, so that would mean we have to come back to the projects again, and then we go to design and rules to access this menu again. So last time we went to placement to change the component clearance, but this time we want to come to routing and we want to change the width over here. Okay, so this is something you want to set on your own. So before we saw that it can only be minimum of 6. By default, the minimum width is already 10. So we're pretty much covered actually. But for my purpose, let's change it to something else so we can experience what it means to change the rules over here in this constraint manager. I'm going to change it to 15, 20, and 30. And you can change it to anything you would like based on your personal preference. Okay. So again, this is something that I want to check for my width of the traces. So the smallest trace now I can place in Altium Designer is 15 mil. And the widest trace I can place in Altium Designer now is 30 mil. Okay, if I violate any of these rules, it's going to make the wires look like light green again. So just like how earlier, if I place 2 components too close, it's in light green. Same thing here. It's going to turn the wires into light green if I violate this rule. So this is how we can set the width of the wire. Another thing I would like to set is the via styles. So to set the vias, we have to come to routing again, and it is routing via style, this guy over here. Okay, so we just read the documentations from the PCB vendors, and this says, okay, the smallest hole I can drill is only 10 mil. By default, the smallest holes that we're setting in Altium Designer is 28. Let me change it to something like 15. So the same thing here, I'm going to change this to 15, 20, and 25. Well, actually, we can prefer 28, keep the default. And I'm going to change the via diameter, the diameters of the via, to be 20, 40, and 50. Okay, and press save. And you can specify these values on your own as well. I will give you the path to access these 2 settings. Okay, so this setting sets the width of the track, and this setting over here, it sets the size of the via, which also refers to the size of the hole. And press OK. Okay, now we come back to here and we can start routing all of these components. So to access the wires that we can place here, we need to make sure we are working with the copper layers, right? So we either want to route the top copper layers or the bottom copper layer. But in this case, I want to start with the top layer first. So I will select top layer at the bottom. Okay, and then to access my routing tools, it will be through this interactive route feature. It is the second icon after the divider. Okay, after that, I should have a cross snap to my cursor. And it might be a good idea for us to also change the grid a little bit here, right? So earlier we do this, we set the components placement, we make the snap grid size a little bit bigger, but now I'm gonna place it in 10 mils, so that should be okay. Well, actually, I can make it 5 mils. It's no big deal. Okay. So that just means I have a bit more flexibilities in placing my wires at different locations on the board. Okay, so starting those interactive routing tools, I can follow these guidelines to connect my LEDs with my resistors. Okay, so you've been wondering, what is the effect of the previous settings just set, the track width? Well, that just means when I start routing any component, if I press the number key 3, it would toggle through all of the settings, the sizes I just set in the menu, right? So it starts with, I think this guy is 15, and then it goes to 20, and then it goes to 30. So when you're pressing 3, it will actually have 4 selections, right? So previously in the menu, we only set 3 selections, so 15, 25, and 30. I don't remember the exact number. The 4 selections that you can toggle over here is the width that you set in the properties menu. So that makes up the 4th option. Okay. So what it means is now if you press 3, you can access tracks with 4 different widths. Okay. So coming back to the minimizing noise kind of design practice, right? So for normal signal pathways, I'm fine with setting it to 15 mils. But when I'm trying to route the VCC route or the ground path, those are the ones that will make my track width a little bit thicker, or sorry, wider, right? So for these regular signals, I'm fine with just 15. Versus, let's say for the power over here, I want to make it to have the widest width. Just like that. Okay, so we can minimize the noise and the impedance for the power path. Okay. So you can also see that after I've selected one of the pad, it will highlight the other pads that shares the same net. So those are the pads I should connect those specific components with. And let's see, this wire over here, I want to make it to have the thinnest width and connect it right there. And you can see that after I make the connection, the net line will actually disappear. That just tells me that, hey, you have already made that the connection for that net. Good job. Okay, I will do a couple more examples and show you another scenarios of what happens when you have too many wires on the way and you just cannot get to the other side. All right, so let's say I've finished routing these two connectors and now I'm ready to route this one. However, this line over here, this pad, must be connected with this pad over here. Well, for sure, I can just directly route it from the top, or if I ended up having something else over here blocking my way to reach this pad, this is the time when I need to start using the VIA. So VIA is what transmit the electrical signals from one copper layers to the other copper layers. So what I'm gonna do, imagine I'm driving a train, right? So I may be going this way, but there's something on my way. Then let's actually take the elevator. Let's go through the tunnel by holding the control and the shift key, and then scroll the mouse view to put the VIA on our cursor. Okay, so this is like an elevator that helps us to bring the signals from the top layer to the bottom layer. Now I'll be routing in this red line, in this blue line. And because this belongs to a completely different layer, it does not care about any of the connections on the top layer. It can move freely to any direction, right? So I'm no longer limited by these two red lines over here on my way. I could just bring this wire down to here, and then now I have to take the elevator back to the top layer to reach my destination. Okay, so this is how we can use the VIA to make connections. Okay, if we have too many wires on the way, that conflicts with our path going from one pad to the other pad. Okay, so I will demonstrate another one. Right, so I will first start interactive routing. I select a pad. And then let's say I do not want to go through this way. I just want to go through the bottom way. Then first I will hold the control and the shift key and then scroll my mouse view to establish the vias. And then I can move my tracks from the bottom layer to somewhere near the place where I want to make the connection. And then I use Control Shift again, and then do a mouse scroll to bring the signal back up to the top layer. Okay, so that's how we can make the connections using the VIA. And you can please feel free to make the connections for all of the components here based on the lines. And if, oh yes, and please do not make connections for the ground, because we're going to use the polygon to establish the ground connection. Right, so you can read the net names over here. You can also read the highlighted color. So do not connect anything that's highlighted in blue, but do connect everything else. For the ones that's highlighted in red, you want to connect them with a wider track. Versus the regular ones, you can connect it with the thinnest track width. And I will be posting some of the shortcuts that I used over here. Oh, by the way, something I forgot to mention. So when we're placing the VIA, we can also toggle the size of the VIAs, because remember earlier we have set it in the Rules and Constraint Manager. So changing the wire's width is by pressing 3. changing the via size is by pressing 4. So if I press 4 right now, you can see that this is the smallest size, this is another size, and I guess the other two sizes, their difference is so small we can't even see it. Okay, so that also comes into effect. It shows how the rules we've set affects the way that we route the board. Okay. So this line rule. The first thing we want to set is under design rules and routing with width. And you can set it to any sizes you want. For me, I did 15 mil, 20 mils, and 30 mils. To change the VS size, it is under routing. Routing via. So, routing VS. And I guess I would just post a screenshot of this. That's a lot of numbers to type. And after that, you can basically use 3 to change track width and use 4 to change VS size. It's control, sorry, I forgot to put that down. So control plus shift plus mouse view scroll. And we can put a 15 minutes timer here. Wait, it's already 3:65. Sorry, 3:36. We only have 24 minutes left. Okay. If that's the case. Yeah, oh sorry, continue routing. I might just run through the rest of the steps. Sorry, I didn't keep track of the time. I thought we still have an hour left. Not sure what made me think we have more time. so remember you do not need to connect the ground net. I will show you a trick later that will just automatically connect all of the ground nets with each other. Your via isn't connecting to your wire. Okay. Do you mind sharing your screen? Can I look at what's going on there? Okay, cool. All right, so let's take a look. Oh, okay. So you want to be placing the vias while you still have the wires on your cursor. So let's say you have started this wire over here. Yeah, you probably need to grab the tool. Yes, exactly. And then hold Control Shift, and then scroll the mouse view. Yes, and then left click to place the via down, and then connect. Exactly. Awesome. Mm. When going diagonal, it says your wire is too thin. Okay. Did you set the design rule? Well, I'm assuming you set the rules. That's why it says it's too thin. Let's share your screen and see what's going on there. Okay. It's loading. Okay, cool. Yes, so go to the width. Yes. Oh, you probably want to set it on top. So do you see the three in the middle? Do you see the little golden thing in the middle? Yes. Yes, those numbers, exactly. So change that into 50, 20, and 30. Mhm. And you can change the preferred width into 20 as well. Oh, you probably want to change it for both the top and bottom, exactly. Cool. And then select OK. And then yeah, well, you can change it or you can leave it as it is. It doesn't really matter if you want. Yeah, but I think there is one more thing that we didn't set in the routing menu. So if you can go back to the rules menus real quick. And then go back to width. Yes. Yeah, so set the preferred width to 20 mil, exactly. And then press OK. I think that should prevent us from generating those errors. And I guess one thing you can do right now to remove those little dipped wires or the green highlighted wires would be using the filters to sort of, sorry, I'm just kind of losing my words right now. Yeah, so the pet that's highlighted is actually at the bottom, so you want to go around the part. Yes, exactly. Okay, looks like I fixed the problem. Yeah, so you can think of your goal as to find the minimum path between any two connected pets. Okay, and you do not need to make connections for the ground. You only need it for VCCs and any other net. So everything but the ground net. Mm-hmm. Okay, that should be everything. All right, can I connect wires to components on the bottom layers or can I only connect on the top layer? Yes, you can only connect the components at the bottom layers if they are all through-hole components. Versus for the surface mount components, you can only connect them at the layers that they're placed on. Because here we can go to 3D view. Because these through-hole components, they'll eventually just be us, right? So they already have the connections from the top layers to the bottom layer. Versus if you look at the surface mount components, so these are the resistor, they do not have that tunnels that goes from top to the bottom. So you can only connect the surface mount components with the other components that they're at the same layer. If you want to make connections between the surface mount from top with the surface mount at the bottom, you have to use via. Yes, potentiometer, yes, exactly. Well, sorry. Potentiometers and C2. Since C2 is surface mount, you can only connect them through the top side. Okay, sorry, I probably have to go over time a little bit. So, yeah, it might just be 10 minutes. I'm so sorry. I think I estimated the time wrong. Yeah, but we have around a couple more minutes for routing the board. I will probably don't have the time to go over the draftman's files, so instead I would just post a documentation on Discord channels for you to follow. Or you can come to the homepage and there should be a draftman's files module. This one, preparing production drawings. Step 14. Yep, this is the draftman's. Yeah, I'm so sorry. But of course, if you guys have any question related to those modules, I can answer those questions on Discord.
Oh my Christ.
$30 more seconds.
Oh. Oh.
Okay. That is time. Okay, so coming back to this diagram, I'm going to skip this documentation section real quick, and then we go from polygon pour directly into DRC and then fabrication output. So we should be able to complete it in the next 15 to 20 minutes. Okay. So for the polygon pours, now we have established all of the connections between the... Okay. Okay, Michelle, I'm going to help you a little bit later after the polygon. Okay, so for polygon pours, we have to make all of the connections between all of the other nets except for the ground net. So we can see that there are a lot of ground connections on the board, and we want to connect all of them through a really, really low impedance, low noise way, such that the current do not have a hard time leaving our board. Right, so we can for sure use a super wide track to connect all the grounds together. That should do the job. Or a common practice in PCB design is to establish a polygon. So polygon just means a large areas of copper. So the areas of the copper could be as large as the size of the entire board. And for us to establish a polygon specifically for the ground net, the first thing we want to do is to come to the properties panels for the board and enable board shape over here under snapping. So that just means later when I'm drawing the outline for the polygon, it will be able to snap to the side of the board. And you can think of polygon similar to what we were doing when we're drawing the board shape, right? So we first draw an outline, and then we redefine the shape of the board by the areas enclosed by the outline. So same thing here. We can define a large areas copper by first drawing the outline of the copper and then fill the inner areas with copper. Okay, so to access polygon, I will come to this icon over here. So this is the 5th icon after the divider. Select polygon pour. And I can start drawing this polygon pour around the edge of the board. Just like that. Now I have this entire areas enclosed. I can go to its properties panels over here. And then I could change where I would like to establish this copper. Because I have some surface mount components on the top layers, they cannot be connected by the polygons at the bottom layer. So it makes more sense for me to establish this polygon at the top layer, such that it could not only connect the through-hole components ground, it could also connect the surface mount component ground. Okay, so I'm going to press report. That means establish of the coppers based on the outline. And there I have my polygon. But if you take a look at all of the ground net, these pads, they're not really connected with my polygon. I want the polygon to be carrying the ground net, but it's not doing that because in its properties panels, okay. Cool. Now let's only select the polygons. Okay, because in its properties panel, I have not specified the net over here. So I will specify it as ground. And report. Report just means re-establish the polygon based on the settings I've set. Oops. Okay. Now if we look closely, you can see that the polygon have the copper connections between all of the ground pad. Right, so this makes our job much easier. We do not have to care about making connections between all of the grounds using the wires. The polygons have automatically make the connections of the of the ground nets for us. Okay, and it's not just for the pins for through holes. It's also for the pins for the ground. Right over here. Okay, so that is something you could do when you don't want to make the connections for the grounds manually. Okay, and I guess another thing you want to check after you do the polygon pour is you want to make sure that, sometimes these areas over here, it's not really connected with the grounds to the other side. But I think in this case, we're good because we have this pad connected to this areas, and then this areas is being carried to the other areas of the board. Okay, but that's the basic idea. You place a polygon to make automatic connections between all of the ground nets. How do I do the ground thing? Yes, so we come to this polygon pour icon over here, select polygon pour, and then draw the outline. And after you've drawn the outline, we can select the polygons, the outline that we just put down, and then modify its layer to top layer, and then modify net to ground. I have seen people designing boards where they put both polygon pours on the top layers and the bottom layers. So I'm just going to establish another polygon again. This time I want to put it at the bottom layer, and I want to give it the ground net again. Okay, so for example, if I look at, oh, that's wrong. Okay, so for example, if I look at this polygon pour on top, Right, so this ground pad. It's not really connected with the rest of the ground pad. That means I do not have any electrical connection between this ground and some other ground. Right, so what I could do is to just place the via. Let's make it a little bit smaller to 30 and 15. So I can connect this top ground polygon with the bottom polygon, and the bottom polygon has access to a lot other top ground polygon. And then I could basically place another via. So right now, this ground pad, it's traveling down to the bottom polygon, and it'll travel back up to this ground polygon over here. And I have to make a connection between this pad over here and this pad over here, the red polygons. Right, so that's another way of ensuring that all of your polygons for grounds are interconnected. Okay, after you change something and then it shows all greens on the screen, you just need to report that polygon. So you can select the polygon and then press the report buttons in the properties panels, or you can directly come to tools, polygon pours, and then report all. So that also helps you to report all of the polygons. So report basically means to reestablish the copper area. Okay, so let's give about 5 minutes to, well, 5 minutes, maybe a little bit too much. Let's do 3 minutes. And I will start looking at Michelle's PCB. Hi, Michelle, are you still there? Yeah, sorry guys, I probably have to go over for about 10 minutes. If you have something else to do, you're free to go. But if you want to just stay for the last couple steps. Okay, cool. You can make the VS now. Awesome. And I would just be presenting for the last 10 minutes. Yeah, sorry about that. And actually, for people who have to go, please take the survey before you go. I'm going to post the survey in the chat right now. Here is the survey. so that is time. And hopefully everyone have finished establishing the polygon pour. Okay, so coming back to our picture. Now we're at the stage of verifying or validating our PCB design before we can generate the fabrication files for the PCB. Okay, so to run the DRC, it's very similar to running the ERCs in schematic, but this time we actually come to tools and then select design rule check. So design rule check stands for, that's what DRC stands for. And for sure, you can create a report for all of the errors that are currently presented on your board, because you may be the person who's designing the board and you're assigning another team member to fix all the issues on the board. So it becomes helpful when we have this report file. Now we can press this Run Design Rule Check buttons at the bottom left. This is the this is the rules and violations that the errors that DRC have detected. Okay, and we can also get a better view about the errors by coming to panels and then PCB rules and violations. So this panel also helps us to look at the errors on the board. Okay, so I'll close this document. It looks like so far we have 48 violations, and they're all related to the silk to solder mask clearance. Similar things, I can double click. Well, I usually like to change this to mask, which means if I double click, it would just take me directly to the error. Okay, so it's showing this error because the minimum distance between the current footprint of this resistor is violating the clearance between the silk screen layer and this pad over here. Okay, so there is a way for us to change the settings specifically for the distance between the silk screens and the pad. And we'll be doing it through the same methods. So we go to Designs and Tools, and then we have to locate the settings that is checking for this distance. And we can access the settings by going to Manufacturing, which is over here, and silk to solder mask clearance. Right, so this is the settings we want to change because the default footprint that comes with this resistor violates this default rule settings that we have in PCB rules and constraint editor. Okay, so by changing this to 5 mil, and then we can run the design rule check again under Tools and Design Rule Check. And this time I do not want to generate a report. I just wanted to update my PCB rules and violations. Now I've resolved all of my violations over here. Okay, and that means I have finished routing this entire PCB, and I have also passed all of the rules and design constraints I've set at the beginning of the project. Okay, so I will take the last 2-3 minutes to sort of quickly go over how to generate the BOM files, the pick and place, all of those Gerber files for submitting to a PCB vendor. And after that, I will stay here for about 10-15 minutes. If you have any questions when you're trying to resolve the errors in DRC, or you have questions about generating those fabrication files. Okay, but I can also type this in the chat. This is using Tools Design Rule Check. And the panels that we use to check the violations is PCB Rules and Violation panel. Okay. Going directly to generate the fabrication files. So the first thing we will look at is how to generate the BOM file. We can generate the BOM files by first focusing on the PCB document. It will not show up if you're focusing on a schematic document. And we come to Reports, and we go to Bill of Materials. Okay. How did I quick fix all the, oh, that's through the rules and constraint. Okay, take a screenshot of this guy. So manufacturing sub to solder mask, and we want to change this values into 5. Okay, coming back to here. So to generate bill of materials, reports BOM. Okay, and over here we have the freedom to control what columns we want to display in our BOM. Right, so for example, over here, these are all of the parameters of the components that we saw earlier. If you choose to enable or disable something, this would just add or delete a column from our BOM. Okay, and after that, we can decide what type of formats we want to export this BOM. So it could be an Excel sheet, but I do not have Excel downloaded on my lab computer, so I'm going to do a CSV file. And select export. Okay, and over here, I press save. So normally when you're outputting those fabrication files, it will be stored in the output folders in the project. So to access it, you can right click on the project and then go to explore. This will open up the local file path that is currently storing your local copy of the project. And there should always be a folder that calls project outputs for blah, blah, blah. And if you open it up, this is where it shows all of the output files that were generated, including the design rule check report and also the BOM file over here. Okay, so if I open it up, this is the BOM files I have available. And I just generated through the feature, the reports BOM. Okay. And other than the bill of materials, we could also generate the Gerber files and pick and place files. And to do that, we have to focus on the PCB document again. And we come to files and then fabrication output. And you can basically choose Gerber X2 files and NC drill files. So these are the 2 files that are required for PCB manufacturing. Normally the default settings, that looks pretty good. I would not change anything when I'm exporting my files, but it all depends on the manufacturer you choose and what type of standards they have on the way that you're exporting these files. So let me try generating this Gerber X2 setup files. Okay, it's going to generate this new folder over here that's called generated. And then over here, we can look at the content of those Gerber files. So the Gerber files essentially just information about each layers we have on the PCB. So one Gerber files specify the copper areas for the bottom layer and the copper areas for the top layer and the silk screens, the dextinators we want to print on the board, and so on. Okay, so some of them may be empty, the other ones may be not. So this is the paste. This is when we're using the pick and place machines from the PCB vendor. They need to know exactly where to apply the solder paste to solder the surface mount component. Okay, so other than the Gerber files, we also need to use the NC drill files. So we have to come back to the PCB document again, go to File, Fabrication Output, and then the NC drill files. So again, you have to check the manufacturers for the specifications on this page. And here we have generated the NC drill files. And all of these output, they are available in the output project folder. So let me go back to my projects again. Select Explore. Okay, so this is where it stores all the fabrication file, assembly files that I can send to the vendor. And normally they will ask for a Gerber zip folder. You just need to right click and zip this folder. And this is the folder you can directly upload to one of the vendors that I sent or any other vendors you prefer. So Osh Park, JLC PCB, or PCB Ways. And yes, that is basically the end of this training. Hopefully that was clear. And sorry for going over time a little bit. I will be here until 4:30, which is 6:30 at your guys' time. So if you have any question related to generating the files or resolving your DRCs, I will be here to help you. And I could also put down the steps to generate the bond. So this would be report bill of materials. Fabrication files? Yeah, no, don't be sorry. We're all good. Okay, so to generate the into Discord so I can continue later. Oh, sorry. I've been pasting the past in the Zoom session. Yes, I can do that. Okay. I'm so sorry. Okay, so this is for the bill of materials, and for the fabrication files, you want to first focus on a PCB document. And then we can go to File, Fabrication File. And then there should be a Gerber X2 files. This is for the Gerber file. Or NC drill files. Okay, so coming back here again, after we have passed off the test in DRC, we want to generate the files that we can submit to a vendor. Then we first focus on the PCB document, and then we come to files, and then we go to fabrication outputs. And then we can choose the ones we want. So Gerber file uses more of the legacy settings versus Gerber X2 files, it uses more modern settings. This is something you have to confirm with your manufacturer to see which type of files they prefer. But I think for most of the times, the X2 is fine. I need to edit this message. It's not fabrication files, it's fabrication outputs. There we go. Okay. Again, all of the things over here have to confirm with the manufacturers, but I usually find the default settings to be okay. So the vendors I usually go to, they're fine with just taking the files generated by this setting. Okay, so I will not change anything there, and then I click on apply. And in fact, everything you click on apply, so for example, you might be making some changes in your PCB, you want to regenerate your fabrication files, it will overwrite the previous files that was stored in the output folder. Okay, so I just generated those files twice. And if I go to the Explorer, go back to my project output, it would not show double amount of the files. It would just show the same amount of files, but with the latest version. So every time you apply these fabrication file output changes, it would just overwrite the previous version. So if you want to keep a copy, then maybe just keep zipping them every time you want to keep a copy. But if not, it would just overwrite the files that are currently stored in this project output folder. Okay, yeah, so that's how we can generate the Gerber files. And for the NC drill files, it's also very similar. Come back to, sorry, we have to focus on PCB again. So file, fabrication output, and then NC drill files. So this is what specifies the holes that will be drilling through the board. And it is also required by the PCB manufacturer. So you have to confirm the settings with the official settings specified by the PCB vendor, and then press OK. And you can press OK here again to generate this NC drill files. And this file should also be stored in the output folder as well. Okay, yeah. And after that, the basic idea is to zip the entire project outputs folder and then send or upload the zip folder to the vendor website. I hope that was clear. Yeah. And if you need a refresher on everything we went over today, this is a really good resource to do that. The only thing I didn't go through is the step 14. I'm sorry, for the production output. And in fact, I can do it right now real quick if you guys want, or you can use the time to practice the fabrication outputs and the DRCs. Cool. Okay. Do you guys want me to go over the production files, or do you prefer to use the time to practice? I can do either way. Yeah, I'm sorry for going over time.
You're okay. I know this is a lot.
Yeah.
I would benefit from going over the production files.
Okay, yeah, no problem. So let's try doing that real quick. Yeah, so for the production file, it's for generating the draftman's files, right? So remember, before we look at this design on Altium 365, it comes with the draftman's files that gives the specifics about the design of the board. So you can essentially export this as a PDF and share it with your teammates to explain the design of the board. So to generate that draftman's file, it's just the same as how we're generating a schematic files and the PCB files. We come back to the project, and then we right-click, add new to project, and then draftman's document. Right, so this is how we create the schematics and PCB. This is also how we create the draftman's document. It will allow you to select any templates you would like. We'll start from scratch again, and then just pick default. And select OK. Okay, so now this is the draftman's file. Several things we can do over here. So the first thing we could do is to insert a board assembly view, as by this icon over here. Okay, so now it's the process for you to read my schematics and my PCB, and then to generate this figure over here that represents my board. Okay, so this is the top view of my board. I could actually look at the board from the side by basically duplicating that object, double click on it, and then go to its properties, right? So by far, you probably have analyzed these patterns of placing something down, and you can modify a bunch of things related to that through the properties panel. I could change this, for example, to look from the left-hand side, right? So this is what my board looks like from the left. I could also look at this board from the front side, which looks something like this. Okay. And you can feel free to modify the titles through this property panels again. So I can hide these titles because they're kind of getting in the way on the schematic sheet. Sorry, on the draftman's file. Okay, so that's how we can create assembly view for our component. And next, you may be interested in drawing the dimensions of the board, right? You want to tell the reader what is the size, for example, of this edge of the board. So we can select this tool over here. This is the fifth icon on the active toolbar. And then you basically click on the corners and then drag the measurements out. Or you can directly press on the side, and you can do that. Oops. Never mind, we can't. Yes, so we can directly press on the side and also get a measurement from the side. So that's another thing we can do in the draftman's file. Okay, so another tool is to show a detailed view of the specific sections on the board. So let's say the components at this section is really, really small. It's getting difficult for the readers to look at the details. Then we can pick this fourth icon to draw a circle. And then we can put a detailed view on somewhere else on the board. So now we have an enlarged view of the specific sections of the board. And you can basically use the properties panels to modify the properties related to this view again. Okay, so you can feel free to explore the other active toolbars items over here. You can place a bill of materials. You can also place the drill table. So this is the drill table. that specifies the holes and also the count on the holes on the board. Right? If you are running out of space, you want to add one more page, then we come to the panels button and then press on bookmark. So this will pop up this bookmark panel. And so we're currently at sheet 1, and we can basically add another sheet by right-clicking on sheet 1 and then select add. This will add this sheet 2 over here that allows us to place more components down. Okay, I guess another really cool thing to do here is to get a drill drawing view as well. So this view works really well with this drill table, because the symbol specifies the location of the holes, and this column specifies the size of the holes. Okay. And I'm just randomly dropping things down you can access through this active toolbar. There's so much more that you can do. I guess another thing is the layer stack. We can actually show the layers of the board as well. Right, so here we have the dielectric layer, we have the top copper, bottom copper, silk screens, and the solder mask. And this white line over here, this is actually the via. So remember that the via is the tunnel that goes from one copper to the other copper. This is what the via looks like from a cross section. It's basically a holes we drill through, and then we apply some coppers to the edge of the hole, such that we can conduct the signals from here to here. So other than the assembly view, we can also place down the PCB view. Okay. And that is by this icon over here. And yeah, thank you, Michelle. See you. If you have any question, post it on Discord. I'll be able to follow up with you. Yes, no problem. Okay. And after placing down this fabrication view, you can actually go to its properties panels to change the layers that we want to display for this object. Okay. And you can also stack up other layers on top. So for example, right now I've selected top layers to be displayed, but I also want to show, for example, the top overlay layer. So I come to this layer tab and enable the top overlay. You cannot see it because the top overlay is actually underneath the top layer. So a good way, if you want to show both the top layers and the top overlay layer, is by specifying the layers you want to put on top. In this case, it's the top overlay. There we go. And then you can come back to this layers tab and then enable the top layer. Wait, that's very strange. Oh, sorry. This is exactly where the layers are placed. We need to move this guy up to be on top of the top layer. There we go. Such that we have the top overlay and also the top layer to be displayed at the same time for this object. Okay. Yeah, and again, if there's something you're not familiar with, just hover over your cursor to there and then press F1. That should give you a documentation related to that specific component. Okay, and that's how we can generate production files. Oh, sorry, this is not for production. This is assembly file. Do we have any question? Okay. Yes, if not, let me see if there's any path I should include over here. So to create our adjustments file, go to projects. Yes, no problem. Thank you very much for coming to the workshop. Please remember to fill out the feedback form. It is very important. I will repost it here. Please fill it out before you go. It will only take you about 2 minutes, I think. Go to project panel. Click the project to create a file. To add a sheet. And draftsman's file. So we go to panel bookmark. Okay, I think that should be sufficient path. All right.